Going live. I think we are live. All right, welcome back to the channel. We're back. We're back. Got some overclocking done. I am going to open up a couple things. Get hardware bot here open here. There we go. Let's open this in another page actually. There we go. There we go. There we go. How's it going, Jimmy? Oh, very nice. Doing good, man. How about you, man? Just gotta go over the GTX 770 that I modded up. With just a feedback mod, I will be doing a different kind of mod later on, but capacitors and feedback mods, what I did so far. More or less wanted to get some scores done and to let people know whether or not this is a good choice for them. For simplicity, in a way, it's not bad to do. I would expect a lot of people to be able to do it, to be honest. The next mod, though, would be the vid mod, and that's a little bit more difficult in terms of what you actually have to do, and you actually need more hardware to actually be able to do it. So, oh yeah, internet people. Oh, how's it going, Hooves? Joker crashed out. What do you mean? Feedback mod. So you're basically tricking the controller. What time is it? It's 7 a.m. here. 7 a.m. I've been up since I've been up since yesterday around 10 p.m. Sorry. Yeah. Been up since 10 p.m. yesterday. Feedback mod is so I'll show you a little bit. I will be doing later on in the stream here. Doing like hands-on on this. 9 p.m. It's 9 p.m. there. Jesus. So over here, we got this little controller here. All right. So this controller does a lot. GPIO, the vid. Your vids are different, like frequencies. Well, not frequencies. Boosts and also voltages that go into vid, and then you got feedback, CS comp, which are also part of amperage voltages type deals, and you can only go so far with doing all that anyways. But feedback mod here, feedback is a signal that goes to this controller for the voltage. So adding on a data wire that I have up through here, this will be redone too, and I've redone it a few times. I figured try to shorten up my runs might help some things. It does not. Shortening the runs does not actually help anything, unfortunately. So but yep, and then we'll flip it over. Yeah, I got a lot of capacitors on here. So I redid all these capacitors. There wasn't that many capacitors from the VRMs. I also added capacitors from the power supply, power in, more capacitors here. And then more capacitors for the VRM. So I don't know how many of them I actually added in. Two large capacitors. So I'll be adding more of these capacitors in, and then more capacitors on the core. But then these are potentiometers. You don't have to do two. You don't have to do two potentiometers, just one. These are 47 kilo ohm potentiometers. I wanted to try to get as close to 100 kilo ohm as I could, so that way I can fine tune the voltages as I go. It's in steps. So you start tuning one, you can only go so far with it, and then you start tuning another one. You can go so far, and then once you start getting really, really low into the actual resistance, the voltage will go up a lot more. No, shunt mod, which I do shunt mods a little differently than everybody else. I do shunt mod right to the controller. I don't do the shunt mods right from the RO5s, which I'm trying to do this backwards. Right here. A lot of people do like shunts off of that resistor. I do shunts off of the controller. So it does from power. So power. 6-pin and 8-pin, and then it also does it for the PCIe slot as well. Shunt mod is different than a voltage mod. Shunt mod just makes it so that way the card's reading basically no wattage compared to what it should be reading. So way less voltage, or not voltage, it shows way less wattage. So there's no wattage cap. When I'm on full load with the voltage mod, it reads 50 watts. A max of 50 watts with the shunt mods. And I use 2R2 resistors. So I use 2R2 resistors on top. And that puts it down a lot. Yeah, so this is a completely adjustable voltage mod. So feedback mod. FB, feedback. So whatever's relaying into this little chip here. And it's just a little chip that talks to the controller. Well, it doesn't talk to it. It's a resistance. I've replaced all these little resistors for the FS. It's also for amperage. So this board right now, beforehand, had a max amp of 150 amps with the switch over for resistors. I can go up to roughly 185 plus amps before it trips any over current protections. And now I have to worry about over OVP, over volt protection. Now that's a hard one to do with a feedback mod. Why? There's limits on what you can do. It depends on the tests. Older benchmarks are very terrible for transient spikes. They go up and down, up and down, up and down. I mean, like we're talking like 200 millivolts of voltage up and down, up and down. That's why I added a shoot ton of capacitors. Okay, so we're talking 3 from the power supply in extra. So the one on this side, though, there must have been something wrong with this board. Again, I got this board broken and fixed it up to even work. So I blew 3 caps. Not sure why. I blew 3 caps. I blew the original one that was on there. I replaced it twice, and it blew 3 caps. I'm not sure why. First one, I mean, she shot out like a rocket. And the other 2, I kind of caught them. They're domed up a bit. Focus. They're domed up a bit. And they stink. Oh my god. All on one test too, trying it out to see if I can get things working better, but there's some of its guts. Ugh. Stinks so bad. Then yeah, they're domed up and they're blown. So I completely pulled it out. I completely pulled it out, and yeah, I fixed everything for not blowing any more capacitors. And I'm not sure why. That wasn't from the voltage mod. The voltage mod does not do that. This is power in, right? So this is power in caps from here. Power in. And then VRMs, chokes, capacitors, right? This is your VRMs right here and here. Now I can add more capacitors to them. So all of these here are capacitors I could add to them from the front side here. But I'm going to be doing this on air too. I'm going to be doing testing. I can still put on my faceplate. Oh, there's a cat hair on it. I can still put on my faceplate and then put an air cooler onto it the way it is. Even with the wire hanging there to the feedback, I can still do that. But yep. So I replaced a bunch of resistors onto it, essentially giving me more amperage. So I'm not hitting an overcurrent protection anymore, and I can't find a way right now. I've been thinking of ways to do other small mods to help me out. So I replaced the one resistor though, from it was a 7.2 kilo ohm resistor. And then for this board and its BIOS and the way that all works is it's 150 amp max. Kind of makes sense for the actual VRMs to do 150 amp max onto it. It's 150 amp max. I switched it over to 935, 938 roughly kilo ohm. Sorry, not 900, 9.3 5 to 9.38 kilo ohm. That's what I was reading. Multimeter is pretty good, but not the best, of course, but it's not bad. It's around there, and that roughly puts me up to 185 plus amps max. So I'm not hitting overcurrent protection, so that's good. That's one way to rule things out is switch out certain resistors, and that was one of the resistors to switch out. Feedback mod, I switched it out from. It's like an 8 kilo ohm to a 10 kilo ohm, and it doesn't really do anything really, but I switched it out anyways, and yeah, it really doesn't do anything. I switched it out, and then yeah, everything looks pretty good. I need to clean up the board, as in I need to clean it up for all the flux. I use again, everyone, no clean flux. I got tons of different kind of flux, but I use no clean flux 8341. The stuff is amazing. I have a spare 3080 Ti. Yo, Debitron. If I send the board only, it's cheap. I've lost the screws to 3080 Ti heatsink. You messed up the BIOS update? I mean, yeah, it's not hard to fix it up. It's you just need a secondary card, and then you just plug that card into the same. Yeah, I could fix it, to be honest. It's not that difficult to do. Yep. So yeah, there we go. Feedback pin goes into this NCP4206 controller, talks to controller through this pin, through other means of voltages going to the actual controller to put over to the core, put to the memory, basically put through the VRMs everywhere. VRMs over to the core. And then that email's in the link description. Okay, so here we go. Over here, these are potentiometers. Again, you don't need to use two of them. I have two of them linked together. And yeah, this is how you do it. You got a wiper. Middle one's wiper. Secondary one's just like a ground. than that. If we flip it over, wiper, feedback, ground goes to ground. Now the ground point that I chose was right here. That right there is a capacitor. If you can easily read, there's a plus, so there's where the power is. And what's on the other side of a capacitor, that's a plus, a ground. So that's an easy ground to go to. It's all right. Easy spot to solder to, pretty big. Holds the wire nice and sturdy. I had these wires are very, very long too, so I redid everything. I redid all the wires. And I haven't even put it down yet. I need to get a hot glue gun, so that way I can hot glue it. What you see over here is some of my Gorilla Glue that I had. The Gorilla Glue that I have is like, it's not really Gorilla Glue anymore. It's like dried up. So that sucks. At least it'll be easy to take off. But yeah, holds everything nice and sturdy. And then again, I can still put on the face plate and put this on an air cooler. I don't know if they're ever going to do competitions again for doing the like a GTX 770 or GTX 700 series air cooler runs, water runs, and LM2, or, extreme cooled. Yeah, Gorilla Glue. It's not even Gorilla Glue anymore. It's dried up. It's old stuff. It's been through a lot. Cold and hot. And then, yeah, the probably close to 100 capacitors I put onto here now. I know all you really are seeing there's 1, 2, 3, right? 1, 2, 3, and 2, right? Room BIOS. All you gotta do is set the card up into a dual GPU PC. You use the single card, your working card, to go into the operating system, and then what you can do is basically it will scan roughly the display out for it. You can actually add a BIOS to it, or you might have to. You got the kit to reflash? Oh, you mean you're not doing it right then. Not unless you messed up the actual chip. If you messed up the BIOS chip, you'll have to replace the BIOS chip. But it's not exactly easy to mess up a BIOS chip. So yeah, you got the main capacitors. Again, capacitors from the power. That's just extras onto there. It's just to help, just in case power supply is not putting a nice smooth amount of power through to the VRMs or to the rest of the card, right? More or less to the VRMs, which these are VRMs. I populated basically every single pad. There was only so many before, so these are doubled up now. 1, 2, 3. Oh, sorry, 1, 2, 3, 4, 5, and all these ones. So these 3, that one, this one, and those 2 up top here are all are put in. So you got to check. Sometimes there are unpopulated spots for capacitors, resistors, chokes, and or more capacitor spots can be unpopulated. You have to check with a multimeter to see if you can even use them. They might not be attached to anything, so you might have to have the card running and actually check it, probe it out with a multimeter to actually check. So I checked all these points right here. Okay, there's a cat hair on there. There we go. Yep, I made this card work a lot better. So all these are extras and doubled up. I'll probably double up the ones I have. I'll probably do these ones here. There's one underneath this potentiometer. I'll probably double that up, but flat, like on the flat side. So instead of it being high, like tower it, I'm gonna put it beside it solder. I'll probably do more capacitors on to these two here and these three as well, just to make sure it helps with transient spikes and helps smooth out the actual power. And then I'll probably add on capacitors to the memory chips to see if I can push the memory a bit farther without any cooling, just air on the actual memory chips. They actually do pretty good. They do 2100 megahertz, 2100 megahertz. So basically like a plus 700 for testing. I'll probably add capacitors onto all the backside of the memory chips, and I'll add on more capacitors to the actual GPU die, the back of the GPU core. So all these little guys, I'll add on capacitors too. So I'll probably desolder these big capacitors right away. I made my own legs since I have donor board capacitors. I got a bunch of donor board capacitors here. These are 2.5 and 6.3 volts. And technically I could use these too if I wanted, but I put on some 16 volt 270s. This is a big 270, a small 270. So this is actually a pretty good capacitor. I do believe this is made by Mitsubishi, and this one I'm not sure. So again, I'll add more capacitors. So this right here, this wire, some people are wondering what this wire is for. So I can attach a my probe, my multimeter. To test voltages, it's pretty easy. So basically, with testing voltage, you could take a multimeter. Right, right, you gotta take your multimeter, and you gotta be able to have your positive side go to some sort of spot on it to show where positive charge is, basically. So that could be your VRMs from the actual power, your actual 12 volt power, your VRMs, or the core, or even your memory if you wanted to. I haven't done any kind of memory mods on it yet, so eventually I will be. This is just soldered to a back of the capacitor onto the positive side. And then it's just hands free. Then the ground, you can literally just put it in through a ground point. Yeah, it's a GTX 770. I don't think BIOS fail. Well, I mean, how would you fail the BIOS? Why don't you just, do you not have another card? Or did you mess around with the flasher and you flashed it and didn't do it right and you completely bricked it? I have a video out there showing the easiest and simplest way. It's like simpler than anyone's ever shown on how to do a flashing the BIOS. And it works for all of my cards. Every single one. And it's easy. I can even brick a card and throw it back in like 10 minutes. Do you have a secondary GPU? Follow my video. If you have a secondary GPU, follow my video. Boom, you're done. Did you even save the original BIOS? Did you even watch my video? Did you watch my video? I have a lot of people say they like to watch my videos, but then they do it completely wrong. Even a bricked flash, you can bring back a card. And I grabbed the server fan. It chewed up my finger pretty hard. Pretty hard. Yeah, even if you don't have the original BIOS, you can just go onto Tech Power Up. Tech Power Up, search up your card, boom, Bob's your uncle. You got it. You got basically the original BIOS. Yeah, it's not difficult to reflash. But yeah, that's the voltage mod on this. Again, this is the simplified voltage mod. A feedback mod is the simplified. You can put the voltage mod to a vid mod as well to give you a little bit more control on the voltage. I will be doing a vid mod on this card. Probably do the vid mod, probably not live stream or anything like that, but I could do that. I could even redo like all this feedback mod. I never even recorded it, to be honest, because I just more or less wanted to do testing on from my own end to make sure if there's ways to actually make the feedback mod a little bit better. And I have found a couple of ways to make it better, but then there are still limits with it, unfortunately. And on old benchmarks, it's even worse. I was able to get 1.5 gigahertz on GPU Pi, though. It's pretty crazy. No, for 50 series, you don't need the exact one. No. You can technically flash the 5070 Ti to a 5080, I believe. You mean send in an A4 envelope? What card could be broken if you send in an envelope? Yeah, I don't get why it's not working for you. I don't get why it's not working for you. And you went on a Tech Power Up and got the BIOS, right? Like the different BIOSes. Have you tried multiple different BIOSes too? Same vendor, and then you made sure the layout was correct? Because some cards, if it's not the same layout, it won't do it. And then also check to see what controller your card has. Yeah. Hmm. Could be the controller. Error code 43. That's an odd one. Because error code 43. Error code 43. Man, what code was that again? Yeah, that's what I thought. It was just because it's trying to load up the actual GPU driver. Do you have a secondary card? Right? You have a secondary card? You have for a secondary GPU, the best to have for a secondary GPU is a GPU close to that GPU. So that way, when you load up the drivers for your main GPU that you're going to use for display, it's close enough to where you can use the same driver for the secondary GPU. But Davatron, yeah, that code is what I thought. Code 43 is when it's trying to load the driver for it, basically, right? It's trying to load the driver for it, but it doesn't. There's an issue with it. On your 50 series card, whatever one it is, 5070 Ti, I forgot which one it is, MSI, Gigabyte, and all that, they can all use a different controller right? Controller, and then that could be built into the actual. Well, for driver, it should still work. Yeah, if you had a secondary GPU there, Dab, right? You have a secondary GPU you could use, right? Or an iGPU? Or just a secondary GPU? Like, technically, you could use your 1080 Ti, right? Or something? I don't know if you did, Hooves. I have to see pictures of you or doing it or actually showing to see if you're doing it right. Nah, see, don't use an iGPU. Use a secondary GPU. So that way, when it loads up a driver into your main GPU that you're using for display, you can actually sometimes just be able to use that driver onto the card that's having issues. Force the driver, basically. Or sometimes you have to give it 15 minutes, or not that long generally for the newer stuff. Yeah, yeah. 4070 Ti with no 4070 Ti would load up too new of a driver for the 3080 Ti. No, it should still no. Yeah. You can use a 4070 Ti. You couldn't use the 6750 there, Hooves. Use the 4070 Ti as your main. Put the 3080 Ti in for second. But if you don't have a cooler for it, what's the point of even trying to get it working? Yeah, so you can do that, and then when you're looking in Device Manager, just for a test, right? Because I'm pretty sure I know what you got. A lot of people are having issues with. It's fine there, and then we'll do that. Boom, Device Manager there. Can we all see it? Oh, hopefully we can all see it. So Device Manager. Ooh, we can see my mouse. All right. So what you're not getting right is it's not gonna show up here. Just scan for hardware changes. Scan for hardware changes. Let it do its thing. It might take a second or two for it to be like an unknown device. Oh my god, it's an unknown device. But generally, when the display adapter is a GPU, it shows up as a display adapter still. It's just showing it as a Microsoft basic display, basically. That's what they are. But that's what it'll show. And then what you want to do is update the driver. I can't do it on this PC. I'm on this PC, so I can't really do it. But you got to update the driver. And then you're going to have a driver ready for it. Basically, whatever driver it is, 5070 Ti, 5070, 3080 Ti, whatever, and then use that one. It's the only way you can do it. For a lot of BIOS flashing, overriding the flash BIOS is the only way to do it. And it's do at your own risk. If you don't know what you're doing, you should not be doing it. If you don't know how to flash it back, even though you've bricked it, don't do it. I literally have in my video how to do it. Flash any card. Sometimes though, there's issues with the actual BIOS, the VBIOS flashing, just due to the fact they have different controllers on them. It worked, but then it just didn't work. The only card I'm having an issue with, and it's probably due to the fact the controller on it. So my 1080, the 1080 Strix that I have, it's a 1080 Strix OC Gaming, and I'm not sure if there's something a little bit different than the Strix OC, because then I can use the XOC BIOS, but I can use everything properly with the XOC BIOS, but it messes up my memory. It puts my memory into limp mode. The core's fine, but it puts my memory in the limp mode, and I'm not sure why. Certain circs? What do you mean? What do you mean? What do you mean? Yeah, I haven't had any issues. 10 series. Yeah, you could do it. Yeah, you could do. Yeah, it's just a 2 GB card too. That's also just a 2 GB. It's just a 2 GB. Let me give you a second. Oh yeah, I got this already open. What am I doing? We already got it open. Alright, we're gonna show some scores now. Show some scores. Boom. Oh, well, I guess I should do... Boom. There we go. There we go. Oh, I don't have... maybe I should just do this. And then we do... And then we do... Yeah, you're going to go so far with that. Then with also doing like a voltage mod, you gotta be kind of careful with that too. You'd want to do a voltage mod and then also a power mod. Nova, what's up? So what I'm gonna be doing with the GT610 most likely the GT610 is doing a power mod. So that way you can give it 12-volt power. Not from PCIe slot. You can actually give them power with a 12-volt. And that's when you have to be, yeah, when you're doing voltage mods on like those cards, yeah, you gotta be careful. Nice. Yeah, it seems like Team Weg's trying to get a whole bunch of people in there now. Splave left. Splave left. He went to Warp 9. Warp 9, I think it was. So yeah, so here we go. We got so yeah, we're now in 6th place in Canada for this season. Top 347 now worldwide. For career, 170 worldwide for this season. And we're still just getting started, basically. We're still just getting started. Alright, submissions. So we got some, as you can see, some GTX 770s. We got some points on some of these. So we'll go for GPU Pi 1 billion to show the... Well, that's not the one I wanted. Why is it only showing 1.4? What's 1.5, is it not? No, 1.4. Ooh, wrong one. Which one is it? There it is. Right here, 1.5 gigahertz. 1.5 gigahertz. And 1.5 gigahertz took 1.44 or 1.45 volts. This took a lot of volts for 1.5. But yeah, a lot of volts. It says the boost was 1.491. No, I was at 1.5 1.515. It's pretty good. Temperature from 21 to 33 degrees Celsius. That's water block for these GPUs. It's really good. Again, 1.45 volts. It took a lot of volts, so we did pretty good. We did pretty good for that. I was gonna do more runs. There is another one that I canceled a couple times. To do GPU Pi 32 billion, it's like an hour-long benchmark. An hour long. And I just didn't want to get too hot at that kind of voltage, so I'll wait until it's chilled when I do chilled to do that, and then we'll probably be able to do a little bit farther than 1.5. How's it going, Gary? I've been working on voltage mod. GTX 770 did a feedback mod for voltage mod. And now we're just going to go over some scores right now. If you want, I can go over the card again and show what I've done to it. All the capacitors, all the ceramic capacitors, all the aluminum capacitors as well. What about Ozzy? Cloudgate, I've done better. I've already done better. I just didn't put it as a new score. I'm trying to. All these scores that you see are on basically stock CPU at 4800 megatransfers per second RAM. Okay, I wanted the GPU to be the beast on all these runs because I'll be redoing these runs later on with the 13900K overclocked. As well. These are all very basic runs. Okay, all right. Cloudgate. This is not my best run. I did almost 49,000. Again, stock CPU, higher overclock. Just wanted to find my fine tuning. The feedback mod is a bit of a pain in the butt because depending on the actual benchmark, the transient spikes can be so bad that it just shuts off the VRMs onto you. Because of the voltage, there is no. I basically raised the actual current limit. There's OVP and OCP. OCP over current protection and OVP over voltage protection. Now, even though I've done 1.45 volts, actually over 1.45 volts for certain tests, those are not the same kind of tests as basically a full 3D benchmark. It's bedtime, Mr. We'll go get some sleep. So, the over voltage protection still kicking in with it. These pictures are not with all the extra capacitors. This is old pictures basically. This is an old run as well. And then yeah, with extra capacitors and all that. And then this isn't actually touching anything. It's not. That's why it's showing 0.2 millivolts. It's not touching anything. Yeah, so I'm gonna try to do well over 50,000 points on this one. When I get it all fully tuned and chilled, guaranteed I could do over 50,000 points. Again, I was almost doing 49,000 ambience with a stock CPU. So then we'll go to here. That was Cloudgate. Firestrike was pretty good score. I was actually very impressed with this score. This score was done with a 5.8 on P cores though, and only 8 E cores. For this benchmark, it's 8 P cores and 13 E cores for the best score. I did 8 performance core and 8 E core, all right, with hyper-threading. This is still not even the best. I'll be running this at like 6.1, probably 6 gigahertz on the P core and probably 4.5 or 4.6 on the E core, which will help quite a bit as well. Again, just a quick run basically. This is all GPU 1.355 it says there. I was not, is actually 1.379. I'm not sure why GPU Z shows lower than what it actually is. That's why I don't trust it. But pretty good score overall, 54th place, and I'm hoping to get around the 30th actually for this bench. From what I was checking for where I should be over 30th nuts and bolts, part of our team, and I'm hoping, because I was checking on what I can do, again checking, probably be able to beat out a bunch of these scores. Again, yep, that was Firestrike, and we got Firestrike GPU. I did 9,489. I just used the same one. I could probably outbeat this as well. Firestrike Extreme was actually pretty good too. I was quite happy with the Firestrike Extreme. Passed no problemos. 4,320. Legendary on this run there. Again, for 3D Mark, 3D Mark's so easy to get first place. Again, it's hardware. It's all your hardware versus same hardware. So I got the best score. This 4,226 was my score, then I outbeat it. Just by overclocking a little bit farther. So 1.379 again. 1.379, almost 1.4. Should be able to run 1.4 gigahertz through this when I do chilled easily. Oops. Ultra, I have not done Ultra. I did a couple of test runs onto it. It kept crashing on me, but it's more or less because I just didn't want to raise the voltage. After these runs, it got pretty warm, so up to 40 degrees Celsius, and that's a little high. It doesn't seem like it's high, but when you're starting to put in over 1.3 volts on these runs, then yeah, it's high in my opinion. And 1.3 is not crazy, but I want this card to last. It's pretty good. It's a pretty good card. Ice Storm, 289,000. This is again, I wrote a comment on it. Feedback mod plus caps only. CPU stock. RAM is stock. 1.345. And I'm hoping to do about 1.4 again. Same 1.330. It's not 1.345 is what I ran it at. Stock CPU. I'm pretty sure I can get a really good placement on this. I'm already 5th place. I might be able to get first place. To be honest, I actually might be able to get first place. He did 6.4 onto his CPU, so that helps him a lot actually. But his graphics score 455,000, and he is only at 1.288. So, if we go back here, show ya. 455, 474,000, and that's, I could do better. This is all GPU. I wanted to see how far I can push the GPU, only the GPU, not worry about doing anything really with the CPU, which is going to help this score a lot, by the way. But 474,000 on GPU score. That's where it's at. 5th place overall for that. Morning there, Garlic. It was BBSE. That's good. That's good. So yeah, I'm pretty sure I can get first place, which would be a good 50-pointer for me. For this when I do chilled, and actually, because everyone's doing crazy on their CPU. 6.1 gigahertz. 6.1 gigahertz. 2.41. I think he was around that. Yeah, 2.41. Again, that's a lie. His graphics score was pretty good, but I'm almost 10,000 points higher on graphics, and my physics score should be pretty good as well. So yeah, I'm pretty sure that is what I can do. I probably get a first place with that when I go chilled, or just tune my CPU to be honest. Ice Storm Extreme also got 5th place. Again, just worrying about the actual GPU, not the CPU. CPU is not overclocked. Stock. I don't know why I have this showing that it's overclocked. It's not. It's stock RAM. And 1.304. That's not 1.304. It's 1.319. So again, probably get another first. I already have a first place. I got a first place down here. First place for Geekbench 6. Was able to do it. 1.410. 1.45 is what I ran this at. 1.432 I ran at actually 1.45 gigahertz. That's what gave me the first place on that run. Not that hard. There's only five people have done this. I mean, it did outbeat Wabasuki. Wabasuki did outbeat him. I'm not sure how he's on a single stage. What is he on a single stage with? 1.4 gigahertz on a single stage? Oh, he didn't do any mods. No mods. That's why his score so. That's why he can only do so far. No mods. One sick. One sick. I don't really like that. I really don't like how you click on something like that and it does that. Kapow. Was it just terrible XMP or? Yeah, that's why I got the first place there with the GTX 770 with just feedback mod. Again, I will be doing a vid mod, which is a little bit, in a way more work. But what I've done to the card already when I do the vid mod, it's gonna help a lot. Like I said, I did a lot of capacitors onto it as well with the vid mod or the feedback mod. And I'm gonna add more capacitors to it. There's gonna be a limit on how much the capacitor actually work, but from what I've done so far from testing from beginning to adding on certain amount of capacitors to certain places, it's helped a lot. So the max I was able to run this card at before was 1.254 gigahertz. That was the max I could run this card at. And I've gotten it up to, so GPU Pi, max on GPU Pi I was able to run at was chilled air, 1.354 gigahertz, and now I did 1.515 gigahertz. And then for other tests like Cloud Gate, 1.254 is the best I could do. Every other benchmark basically 1.254 is the best I could do, or 1.219 gigahertz. And then with the feedback mod, it's like 20% in gains there. And then when I do the vid mod, I should get some pretty good scores. Now, I'm not going to get it first on every benchmark, especially all these benchmarks with Salty. Watch My Debt probably is another one that I won't be able to as well. Just due to the factor on LN2. See, liquid nitrogen, 1.724 gigahertz. And there's basically a limit on voltage. 1.6 volts is basically the max voltage you actually can put into one of these cards. Crazy, man. Crazy. LN2. He's only using 1.52 volts. So that's pretty good. He's still within. He's got more in the tank technically. He still has technically more in the tank. You can do 1.6 volts. Negative 153. He probably took away a temperature sensors onto it as well. So I'm pretty sure on these cards, after a certain temperature, it's either negative 30 or negative 60. You'll see a lot of cold bugs. So you have to remove temperature sensor. Bazinga. Bazinga. So, the benchmarks that were not half bad to run. Cloudgate was alright. Fire Strikes was a good one to run. So, I'm talking about as in how far you can actually push it before transient spikes hit and then it just shuts off the VRMs, basically. Just you get no display. That's basically what happens, just no display. And that's not for technically overclocking it with the voltage and that's not what's causing it. It's just it cuts out the actual VRMs quickly and then it cuts out your display and you have to restart the PC. So Fire Strike wasn't half bad. Ice Storm, it could have been better. Again, I could have pushed it farther. Time Spy wasn't half bad. Skydiver sucked. Time Spy wasn't half bad. I could do. I've already done testing this morning actually. Not half bad. I could do better. About 2,900 points. What I can do right now. And then when I do cold, it should be better. And then actually overclock CPU, stock. It's all stock CPU 2 runs. Vantage kind of sucked. Kind of sucked. It kind of sucked. 3D Mark 03, it sucked. 05, it sucked. 06, it was terrible, man. It was terrible. Oh my god. The worst. I mean, like, I'm talking, I had to run it at 1.24 volts. That's it. If I went past 1.24 volts by even 1 millivolt, it would just go. It was so bad. It was so bad. Time Spy, and Firestrike over 1.3 volts it was all right. For 06 though, 1.24 volts, that's it. And the max voltage you can get without doing a feedback is 1.212 volts. All right, 1.212. That's like 28 millivolts that I get. That's all I get to have extra. That's it. It was bad. Entry, 3D Mark entry sucked. Extreme and performance, not bad actually, not bad. Entry though, 3D Mark 11 entry, it sucked. We're talking like 1.235 volts, and 1.235 volts. Extreme performance, 1.27 volts is around there. It's all right. 1.27 volts, which helps quite a bit. 3D Mark 2001 SE, not bad. I did retestings, and I'm around 200,000. I'm around 200,000 on retestings. I'm not sure if I have any pictures. I'll have to see if I have pictures of those. But yeah, not bad actually, not bad. On stock CPU, not bad. GPU Pi 1 billion. However much volts I wanted to give it, it was fine with it. 1.4, I went all the way up to over 1.465 volts. That was I didn't want to go any higher, and I didn't do long runs onto it. It's just like a quick test run. Yeah, it's fine with it. It's fine with the voltage. I didn't do GPU Pi 3.3. It's a kind of annoying one to do. It's fine tuning it more or less to be stable for the last pass, basically. For some reason, the last pass on that's not bad. I was running at 1.55 gigahertz, so not bad. For Geekbench 6 compute was easy, as literally like a first run onto it. It was easy, 1.45 gigahertz. It was actually really easy. Unigine superposition, not bad actually as well. Could be a bit better. I'll take pictures next time, or I'll do maybe live. Maybe I'll do live and show the actual voltage, the multimeter hooked up to it, to show the actual fluctuations of the voltages, as it does show fluctuations of voltages. It's just not like an oscilloscope, basically. So you won't really see like any of those real transient spikes. It will show some spikeage. It does not show the actual transient spikes like an oscilloscope. Maybe one day I'll get one. But yep, there you go. No, it hasn't been cool here. All these runs were at ambient temperature of 22 degrees Celsius and 25 degrees Celsius. So it's not like it's cool. It was cool at all. Nah. When I do chilled eventually, yeah. I will be. Then I didn't do the 8K optimize, and I didn't do Unigine Heaven yet. These are some other good pointers I can do. It was more or less for these legacy benchmarks. So legacy benchmarks, the older benchmarks like the Vantage, 03, 5, 6, 11, and 2001 SE. Aquamark I can't seem to open up. I'm not sure why. Maybe I have to re-download it. I wanted to run it, but I can't open it up for some reason. I don't know why. It wouldn't let me open it up. For a lot of these benchmarks, these legacy ones, the transient spikes or something is making it so I can't use a lot of voltage. 3D Mark 2001 SE, not bad though. I can do over 1.3 volts just fine on it. And I'm talking 1.3 volts on load. We're not talking voltages like not on load. Not on load voltages can be a lot higher, and it's fine. On load voltages, it's different. I'm not sure why. Again, I have no overcurrent protection. Basically, I've raised overcurrent protection. The only thing that could be leading and causing issue of this is over voltage protection. And I'm not sure why the over voltage protection does not work for tests such as GPU Pi when I can do as much voltage as I want, basically. That's what it doesn't make sense. So these transient spikes, and even though I added all these capacitors, and it does, adding the capacitors helps quite a bit, and actually helped for the benchmarks for ASIN gave me more points just by doing all these capacitors. Actually gave me more points. The efficiency is a lot better. So, yeah, brutal. Brutal. Let's just say a lot of testing, a lot of trial and error. Again, a lot of things that I wanted to try out myself and see if there's just ways to make. I already knew the feedback mod was not going to be the greatest. It's not, because there's so many things after adding voltages for driver as well, part of the NCP as well, and NCP 4206 controller. The drivers are part of that too, as in it's linked for how much voltage, how much amperage per card for your BIOS, so your BIOS and driver. So there's a lot of things. I didn't really have too much issues besides two caps blowing, but that was probably because the card itself had something wrong with it beforehand. Because it blew and blew, like I blew three of them. Like I said, I blew three of them. Three capacitors. Replacing them. So replaced, still blue. Replaced, still blue. So I'm not sure what could have caused that. Again, I got this card broken and fixed it up and it was working, but maybe just because the extra voltages, and then when it hit a certain, the VRM hit its over current protection or voltage protection, it shut off the VRMs. It backtracked voltages, or the voltage from the power supply hit that capacitor, and because something else was wrong with it, it couldn't discharge it properly, and that's why it blew it up. That's one of the theories I came up with, but I don't know. But yeah, it's doing pretty good. It did pretty good. I was quite impressed. It could could have done more testing than that too, but I've done a lot of soldering, and I can go over some of the soldering. Maybe I'll set up the camera here and show you the soldering. Except for it doesn't look pretty just due to the fact there's still flux all over the board. I haven't cleaned it up. I have not cleaned it up yet. Now, should I show it? It's, again, it just doesn't look pretty. It doesn't look pretty. I'll get the board all cleaned up eventually, and then take some high definition pictures of it. Again, I did it this way too, so that way I can put it on an air cooler. Maybe I'll do that later on too, is throw it on air cooler for the next stream and show performance on air. Because the air cooler should be able to handle 1.3 volts, no problem. Should. So this side here, again, it's just the feedback mod for the NCP 4206 controller. So we'll move the mic there so we can all hear. So there's a controller, boom boom, Bob's your uncle, NCP 4206 controller. Again, it does all the power for the board, blah blah blah. There's the feedback, goes to that pin right there, blah blah blah. Focus. That little guy right there. And then, yep, that goes all the way up to potentiometers. it gets hooked into the potentiometer. Potentiometer. Middle one for the wiper. This is a ground. Middle one's wiper. So if we go from ground to wiper, we can connect these two. All right. We can connect them and add this 47 kilo ohm and this 47 kilo ohm to make roughly 94 kilo ohm. That's right. That's right. So we're close to 100K, which makes things very, very even through the voltage regulating through the actual feedback mod. So it's basically fairly close to the actual voltage that the card should read right off the bat. And then we got the wiper, right? And then we got the ground. We got this ground, and that ground goes all the way over to here, to this capacitor ground. Fairly simple. Fairly simple. Now these capacitors are for power in. Goes over to, so through here, see these capacitors. On the other side, we got VRM. Starter of the VRM right here. Ooh, fancy. I have not added any capacitors onto that. I will add capacitors onto that after, I don't know, probably after the stream. Now, again, we doubled up capacitors that were already there for the first test. Doubled them up. Now, there's all of these pads were actually unpopulated, but could be used. Could be used, which is great. Great. Amazing. So I did afterwards. And then I added onto these bigger caps onto these little SMD caps. These are 16 volt 270s, 16 volt 270s, just a smaller version of this. This is actually a better make though. These are smaller. Then we added more caps, some more ceramic caps to the back of the GPU core, and I'll add more of the little guys later on. Because I didn't want to deal with it. I just didn't want to deal with it. I asked DJ for footloose. Footloose. These capacitors adding on to doubled up helped a little bit. We're talking a little bit. Adding all these helped a lot actually. I still have that pad and that pad that actually add on to. Still have to add on 2 more. Just I didn't have any more desoldered off a board, and then I have to check every single one of these that I added on. I checked. These are all 22 microfarads. All right, all these little ones, they're 22s. 22s. I wish I had 47s, but these are 22s. 22s, good enough. And adding on that many, good enough. Same thing with the back of the GPU, 22s. I just wish I had more of them. And then, I don't know if we can really show how good the soldering job is. It's pretty good. It's pretty good. As you can see, it's pretty good. That's what some good flux and some decent solder works for you. Same thing with the capacitor. These ones, capacitors, did pretty good on the capacitors as well. These 2 ones that I put on quickly, I put on with actual wire, so that way they can be just in case, because I knew I was gonna be doing a bunch of solder and a bunch of taking out of the system and redoing. I want to make sure that they can move around, have a little bit of flexibility, That's about it. And then added on the actual from the actual GPU core, the actual voltage that's going to the GPU core, put to the positive end of this capacitor just to make sure it's as close as I can get to the actual GPU core as well. And then just added on a wire so that way I can just hook up to the multimeter. Just helps to check voltages. Yeah, actually, yeah, the good flux helped a lot. I mean, it really was quick. And then for a lot of the capacitors, I just used the hoof style. Focus. Hoof style. I used a a hoof style. So, and then for helping out, just heat it up with hot air quick. Heat up with hot air quick. Blow it around, heat it all up. The hoof style though. And then we got this like this, and then we do this, and something like focus your back. There we go. Hoof style. So it's a hoof, as in it's just an angled tip. It's got good thermal mass. Boom, boom, boom. Easy peasy. Then for the smaller guys, for the smaller ones, we're talking the ones where you have no choice but to use a small tip. It's hot air, then use the small tip for the little SMDs. I mean the little ones. Yeah. They're warm. They got warm. That's just crusty solder. Good to leave solder on the tip so that way it can hold solder later on. So I don't clean my tips. And then this one here is seen a lot of hot air as well. As you can see, it's seen my fingerprint as well. Because I wanted to change it out quick. This is a bit thicker. It's a bit thicker than the other one. And then this one here I used for, this one's blued. This one here I used for doing all the SMDs capacitors on the back of the GPU core, because of how close together that they all were. I used that one. It again has some decent thermal mass onto it. You can do fairly quick work, because that's what you want to do too. You want to do fairly quick work while doing any kind of capacitors, SMD capacitors, either ceramic or whatever they're made of. You want to do quick work, quick solder work. Don't heat them up too fast or too much, basically. Don't want to heat them up too fast either, because they could technically explode, but that way you can keep the rating really good. So when I'm desoldering as well, hot air, nice and hot. I mean, we're talking 500 degrees Celsius, and then just quickly put it to the board for like 3 seconds, pull them off. 3 seconds, pull them off. And then once you got the board actually heated up too, it's just move the hot air, grab, pull, grab, pull, grab, pull. It's super, very, very, very quick. Yeah, it's just good to, yeah, it's good to do nice and quick. Again, I got some more tips as well, like a flat style here. This is another good tip to use. I just have not used it yet because there's no real reason for me to use it right now. But this is another good tip to use. And this right here has a coating onto it. The coating basically turns to this one, like this one, and then turns to like this one. And then the one I use a lot of for the small stuff, and I've done a lot of small soldering. It turns like that eventually. And that's more or less because it hits the hot air, and then you cool it down. It hits moisture in the air eventually, and then it starts corroding up a bit. I don't have the money to get really good tips that don't do that, but one day I will. Yeah, that one was, yeah. I wanted to switch it out quickly. I was like, this is gonna be hot. It was very hot. It was very hot. Very hot. Oh, it worked out pretty good. Pretty good. For like desoldering, I just use really cheap soldering paste. For the soldering, putting actual SMDs back on all the SMDs or whatever I'm soldering to, I use 8341 no clean flux. This stuff is just great for soldering. This older Kester is not bad. This older Kester is actually not bad. I'll show it. The only thing is, for smaller stuff, I'm finding it's not the greatest for like the really small SMD style resistors and caps. Like we're talking 0402s or even smaller. It's not the greatest for ultra small work for some reason. The solder does not stick to the component properly, and then when you pull off with the solder, it just seems to want to like pull away the solder. And then the actual no clean, like I said, this is why I recommend 8341. It's just solder. You can pull away your solder, like your soldering iron. You can just pull that away, and perfect little bit of solder, perfect joint every single time. Super nice. This Kester is an older, good solder paste, to be honest, but doesn't, for electronics, not the greatest. A341? No, not A341. 83. 8341. Oh, I closed the lid a little too hard on this one. This stuff is good. I can't say this flux isn't bad. It's not. It's not bad. It's not bad. It's not bad. I'm just fine with the smaller stuff. It's not liking the smaller stuff. It's like for temperature, it's good for temperature. It's also good for being very thin. It's fairly thin. It just could be better. A3 went to new Airbus jet. Sounds like it. Then we'll show the 8341. Got some grime in that. I got a Q-tip. Okay, just dab and go. I just got a cat here and there. There we go. Dab and go. Grab a bunch. I'm gonna have to grab some more of this probably eventually too. Grabbing it by these tubs isn't bad. I like to be able to buy bulk of this stuff eventually, so that way I don't have to buy it quite often. But yeah, this stuff, 8341. Oh, so good, man. This stuff works so good. And then just general purpose flux, all around flux. It's just good for desoldering, just to help transfer that heat to whatever board component that you're trying to desolder. Makes for quick work. It's cheap. Yeah, exactly. That's right. Down and go. And this cheaper stuff. This stuff here, like it gets over 25 degrees Celsius. It starts turning watery. I gotta watch it because it will start spewing out. This stuff isn't bad though. Just for not soldering electronics, it's not bad for actually desoldering, and you can get cheap. So that way you can have solder for desoldering, and if you're like me, off of donor boards and that, or just desoldering stuff, and you just clean it up, and then you can use the good stuff for soldering too. I was using 50/50. I was just using some 50/50 solder. Generally I would be using my smaller, it's almost a 50/50. It's like a 60%. It's more of a 60/40. It's a little bit softer, basically. But this is core solder. This is core solder wire. So it actually has flux in it. This does not. The 50/50, the solid. It's not a core, it's solid. Does not have flux at all into it. And for some reason with high temps, it can oxide fairly quick. And that'll more or less be the tin in it. That's why the 60/40 is not bad. 60/40 is not bad. And then for desoldering capacitors, especially these higher end ones that I got, these higher end golds that we got here, desoldering them, I use indium. Yeah, I got a bunch of good caps off the boards. So took a lot of capacitors, all ceramic ones off of old GPU. Again, you check them on board, check them off a board. So you always want to check before you put them onto a board, after you on the board, afterwards as well. So that's why it takes a while to make sure you're getting things proper. And then again, just in case you put too much heat to it and you actually change the value of it and kind of corrupt it a bit, it's good to always check. Took capacitors off this one already, as you can see. Capacitors are gone. Capacitors are gone. Those are the 2.5s that I have. The motherboard here, I still have a lot to take off of this one. So a bunch of 2.5s here. Bunch of 16s, I think. Bunch of cheaper 16s that are not something I want to use for modding a GPU per se. I wouldn't. I mean, you could. It's just you want low ESL. And then I've already basically stripped this board of a lot of stuff. This is one where I showed blowing up the capacitors, and that's why there's capacitor guts everywhere. Up here and down here, capacitor guts. That's not the aluminum style, that's the actual packed. These are the packed capacitors. I'm not sure exactly the name of the other one, the cheaper ones. These are aluminum style though. And I'll be desoldering these. It's just they're by big old chokes, so the heat takes a lot of heat. Well, I'll get all these capacitors too eventually. And then I got those two and these two. They're all two. So these are 6.3s, and these are 2.5s by 270s. And then there should be one more, yeah, right here. That one as well. I'll get that one as well. And I'll desolder the chipset too, just to have another chipset, and then eventually I'll do a display on it. Yeah. Yeah, this is the donor board. Donor board was broken. Pins were all crappy. I've used pins off of it, fixed up another motherboard, to be honest. But I couldn't figure out what was wrong with the board. Like, I don't know. I really don't know what was wrong with this board, so I just been using it as donor parts. I've taken a lot of ceramic caps off of this. Basically all the caps. I'm gonna basically probably strip everything off of this board eventually, and then have this board as like a showpiece board, just as a bare board, basically. It is, yeah, proprietary. Yeah. 16s? No, the 16 volts are good. Even though let's say you have a 12 volt power source, you're gonna use a 16 volt capacitor. That way you have there's overhead, there's headroom. That way that capacitor is never being fully worked, and just in case the voltage actually is higher than the capacitor at some point, it doesn't overvolt the capacitor, which could fry it or just wear it out or heat it up more. So yeah. For a lot of actually what I could do with this as well is just add a bunch of 2.5s, but I probably won't. Just for the headroom. So when I do the vid mod, I will be probably going up to 1.5 volts. For any fluctuations, I want to do probably a 6.3 volt. I've been looking at capacitors by bulk, 50 capacitors at 16 volt 270s, or 470s, and fairly small 470s too. Microfarads, NF microfarads, right? So they're 16 volt 470s. For 50 of them, you can get them for about $15. That's not half bad, and they're not half bad caps. Now, Nichicon, to get them through like Amazon, it's gonna cost you like $80 for like 10, like $10 a cap. So I won't use the good Nichicons, unfortunately. I'll be using. I'm pretty sure they are Mitsubishi, to be honest. Not like Mitsubishi, the car manufacturer. But they're a good rating actually for people saying they're actually pretty good. So those I'd probably get, but for everything I've seen done on this board, I did it with spare parts. All spare parts, all free. All free. 100% free. Gave me 25% uplift from my best scores I had. From chilled scores that I had, 25% up on. I did it on ambient, so and it's saying that's a win already for free mod for me. And again, if you have donor boards or anything like that, you can do this. If you have a potentiometer, these potentiometers aren't even made for this. Potentiometers that I have on this board, these pots here, these pots are for fans, for fan controls. These aren't even the greatest pots. They work really good though. Like, they actually work really good. Those are from fans. And actually, I can get rid of one of these, but I can probably keep this the way it is. I kind of like it. I don't think anyone else is going to do it this way. And then I have more of these. Then I'm going to be doing probably the GT610. Right there. GT610. Right there. I probably won't do the GTX 260 squared. Just due to the fact it's in mint shape, and it's actually in really good shape. So I probably won't do the 260. The 8600, actually no, maybe I'll do the 8600 GTS next. It needs it. It's a good card. I did testing on water, and it's up on already by modded cards. Like, we're talking maxed out the sliders, and that's as far as I can do everything already, and it's not even modded. And then once I do the mods and then do a certain BIOS onto it, you can do slider way farther on the slider. But yeah. So I'll probably do the 8600 GTS next. Or, I mean, I should see what I can do for the 9600 GT as well. Because I gotta fix it up and get it working again. I gotta figure out what's wrong with it. There are a couple components missing onto it. I've already searched up the actual controller for the memory chips. The Rich Tech controller. Again, thank you, Excaberries. Excaberries, you're amazing for letting me know that's a Rich Tech controller. I already knew it was a memory problem due to the fact it's right there by the memory, and because it actually loads into, like, I can with a secondary GPU, I can see the G9600. It's just not showing display. Shows me that it was memory of some sort. That's generally an issue with memory. If it's not giving me a display at all. But yeah, I'll get the 9600 GT working and maybe mod it, because that would be a better board to mod than the 8600 GTS. Just for, I mean, I could do both. I could just get rid of the mod and put it over. But the GT610s, it will be just a funny one to do. No power, like, make it so that way I can put 12-volt power source to it. It's actually really cool, actually, how to do it. In my opinion, just seeing it, like, first time actually I saw the GT610, I was like, man, that's pretty crazy on something that you just plug into a PCI Express. I'm like, what are those wires for? I started looking more. I'm like, that's hooked into a 12-volt power source. So that card's getting more power than, than the PCIe. No wonder. No wonder. Yeah, the guy, I'm not sure who figured out how to do that. And then I looked on some forums too, and some people actually, yeah, it's this mod here, you do this for this, and then this mod for doing memory mods as well for this card. It's actually not too difficult to do on them. It's not that difficult. Just a little bit of multimeter work, a little bit of soldering. It's not that difficult to do. Now the vid mods are different. Vid mods is a little bit different. It's not that difficult. The way it works is not as simple as other mods, basically. And the vid mods are one of the best ways to do it. If you have certain cards like an EVGA classified version, you can use their own software that bypasses a lot of things. You can raise up the actual voltage protection, current protection, You can also change the way the frequency changing speed is actually through the software, and then you can go up to 1.6 volts like a vid mod basically as well. So that's why if you have certain graphics cards, it helps. Oh yeah. Yep. Also depends on what you're putting, where you're trying to put them against, but yeah. Oh yeah, thousands. Thousands. I think the GTX 770 has 8 compute units technically. No, is it 8? I think I'm right on that. And it depends on the CPU you're putting it against, right? CPUs have all the way up to 256 cores, no problem. That's a lot of cores. And then you got threads on top of that. There's 512, right? That's hundreds. Now we're down into thousands like the newer GPUs. Now these newer GPUs, 5090 has what, 16,000 compute units around there? 15,800 to 16,000. And then, yeah, the RTX Pro 6000 has 16,000 around there. So it's a lot. It's a lot of compute units. CUDA cores, compute units, CUDA cores. I mean, sorry, CUDA cores. And put these soldering tips away. But yeah, that's what I've been working on. That is what I've been working on. Again, I can still put on. Just wait. I can still put on the faceplate, even with this mod. With the vid mod, I will not be able to put this faceplate on. Well, I shouldn't say that. I might be able to. Nah, probably not. Probably won't with the vid mod. I won't be able to use the faceplate. I'll have to take away one of the. No, maybe I could actually. I'll just have to take away one of the VRM cooling, but then it's kind of no point. The VRMs need cooling. We'll start putting that power to it. I'll be going up around the actual limitations of the VRMs. MOSFETs, chokes. Those are the main ones, so they gotta worry about the MOSFETs. The MOSFETs, they get hot. They get hot. But yeah, not bad, not bad. A lot of testing, trial error on more or less from my own, what do you want to call it, understanding of how things can actually work for the NCP4 206 controller. That controller is a 48 pin controller, and what's the other controller that's close to it? I think it's the NCP 4208 is a 40 pin controller, and then doing vid. Okay, if when you do a vid mod as well, you gotta disable or get rid of certain resistors for the actual GPIO, or else you'll burn out GPIO anyways. So I mean, is it good? Is it the worst thing? Not really, but there's no point because with a vid mod, you need paper. Nope. Oh, yep. I guess we'll do this page. Oh, yeah. Yeah. I mean, efficiency nowadays is a lot better, but still. So, vid mod, vid. So, a vid mod. Hopefully, we can't see that. I guess I'll get out. So, anyways, I'll just show this. So, a vid mod, basically you got vids 0 through till 7, basically, for a lot of them. Some of them don't even go through 0 to 7, and vid 0 or vid 7 might not even do anything. Are you good? Holy sneezins! You got a cat hair in your nose? Well, quit scratch. Quit licking it. Wait. Stop. You good? Hey, look at me. Look at me. Don't squint your eyes. You good? Holy sneezins. So, you good? Holy sneezins. Putting your hair up your nose though isn't gonna keep helping it. So vid, it's a sequence in which, so a vid mod and vids is zeros and 1. Alright? 0 and 1. And how that is determined is some sort of voltage to it turns it to a 1 or on. Voltage off turns it to a 0 off. Now there's a sequence on how vid works. So vid 0 generally doesn't do a whole lot, but I mean it depends on the actual controller. So don't just, for NCP 4206, vid 0 I don't believe does anything. Vid 1, so if you just put vid 1 2, so basically what you're going to do is put vid 1, you get a solder wire to vid 1 on the controller, so you can trace it out to whatever source you can to find it. Vid 1, and then you got to cut ties basically to that pin and put that to a switch of some sort. Or what you could technically do is, instead of putting it to a switch from a power source, so you gotta do it to a power source, so you put the power source to it, so that way vid 1, which is 1.6 volts on NCP 4206, will always be at 1.6 volts. It will always be at 1.6 volts. Then you could put it with a reverse feedback mod and technically lower the voltage, okay? But for just doing vid 1, 1.6 volts, you can put vid 1 on the NCP controller pin, cut it, and then just put it to a 3.3 volt source. Just so straight over to a 3.3 volt source. 5 volt, I guess you could technically do, but I mean, in some ways, some people are telling me 5 volts not the smartest. Just put it to 3.3 more or less to be more safe. But yeah, 3.3 or even like whatever lower source you can find. 3.3 is generally the lowest source of voltage that you can actually find. So just put it to that. So you can put that to the vid 1. It'll always be 1.6 volts, which puts that code to 1, which is on, to a high. To a low is 0. High, 1. 0, 1. Alright? Low, 0. High, 1. Power on to it, power off of it, basically. GPU dominance, most AI data centers rely heavily on GPUs like the H100s that have over 40,000 cores per unit. Multiply that by hundreds or hundreds of GPUs looking at. Yep. But then there's also sources where CPUs. No. CPUs are not irrelevant. Depending on what you're doing. There are applications in where CPUs are going to be more beneficial than GPUs. So if you do like vid 1, like I said, 1.6, and then again, there's a sequence, like I said before. There are sequences. Exaberry's made actually a really good little, like, show you how, if you flip 1 to a high, vid 6 to a high, vid 4 to a high, vid 3 to a high, and then if you didn't do that in a certain sequence, not just flip them all at once kind of thing, because it depends on which one's actually closer to the power source, to the actual controller, on which one gets flipped on first. So flipping the switches manually is a better way to do it, to make sure you're going to equate to the actual voltage that you're trying to get. More achievable by flipping switches, manual switches. So that way you're manually flipping, or no, it's not. I just slammed my finger. It's not bullcrap. So like I said here, so focus. Okay, it's not gonna focus. I'm terrible at MS Paint, and I'm not sure what else to use for. I'm not sure what else to use, but we'll do this. It's all good. We got this. I believe. I don't really believe, but we're gonna try it. I'm sorry for what you're about to witness. Alright. Meow. Again, it's not that complicated. Some people are thinking, oh, you must not know what you're doing and stuff like that. No, I'm not doing a vid mod because I don't have the money to get switches and or other certain components that I'm going to want to do a vid mod. It's very simple. So, we got vid. Oh, this looks terrible. Vid. Oh, yeah, baby. Vid. Mod. Oh, baby. And then you got the controller. Boom, 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 boom. And they got a bunch of little pins. They got a bunch of pins, generally like 40 on some pins, a bunch of 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 pins. Here's your controller. Oh my god, this looks fantastic. Alright, bunch of pins, and we'll say the N C P 4206. Okay, we're just gonna read 4206. Oh, that's beautiful. Beautiful. Alright, alright. Now on my board it's on an actual chip. Alright, it's actually on another chip with a bunch of resistors around. And then over here, boom, 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 a few of them. One goes to overcurrent, CS comp, and then our feedback mod right here. So this is the feedback mod that I had to do. Pin 4 through the side, but it's pin 4, no, pin 42? Pin 42, I think it was. And then to find the actual side of like where you gotta have, so you can search up the actual controller too, which give me 1 second. There we go. Nope. Nope. Hiya! Okay, so we got here. This is the NCP 4206 controller, alright? You can just search it up over at, I call it OmniSense. It's on semi, alright? On semiconductor. But here's the controller, 48-pin controller. And then you can find the indicator, alright? The indicator. Can we see my mouse on there? Or no? Yes, okay. Okay. Pin 1 indicator. Boom. Now, that's how you can find the corner to start from 1 to 48, okay? 1, VCC3, power, alert, SDA, SCL, and ground 7. So if you want a ground source, well, there's one right there. NC, I'm on, IRF, RT. Not actually sure what Rampa is, actually. Feedback. That's one you have to do for a feedback mod. Right there. Feedback mod. right here. That's the one. Pin 14. All right, fairly simple. Now, I did not go straight to the actual pin. If you trace this off of the pin to whatever actual resistors on the board, like I've shown on the actual board. Oh, sorry, no, no, sorry, pin FB, sorry, the wrong one. Fourth pin over from the side, or pin 16. And then I also switched out ILI-MIFS. I haven't done anything with CS Comp yet, just because it doesn't really. From theory, I thought it would work, but in retrospective, after figuring some stuff out, changing over CS Comp for the feedback mod doesn't actually do anything, due to the fact VidMod or the vids will counterdo anything that I do with CS Comp. Like it will actually, the vids will actually outdo and just be like, nope, this voltage should be this. Oh, you went past that? Well, guess what? We shut off the VRM. Not cool. So yeah, the actual here though, the IFS here, then actually doing something with this, and if you want to show, you scroll down. This is actually how it actually all is laid out, right? 3.3 regulator, shunt regulator, blah blah blah, ground, alerts, ILMF, how it's connected to the current measurement and limit. All right, so that's why I did switching out the actual resistor. I switched out the resistor from a 7.2 kilo ohm to a 9.35, 9.38. It's 9.38. I'm not sure why it reads that. It could be 9.4 though, but it reads 9.38 technically on my multimeter. And I switched out to that. In retrospective, that increased the actual amount of amperage before it hit an overcurrent protection, basically. All right. Now, SC comp, as you can see here, goes over to current measurement in that as well. But due to the fact of the VINs on VidDAC here, so VIN 0, 1, 2, 3, all the way up to 7, like I showed on the what I was trying to show on the actual piece of paper, and I will be showing here in a second on paint. You can see that these vids, blah blah blah, go boot voltage and soft start control, and then it goes all off, and then you can just follow how this all actually works. It's not that difficult. It's actually not that difficult. Yeah, so this actually worked for overcurrent protection. CS comp does not, and we can go down. We can show you here. Feedback FB, the mod that I did, FB pin 16. Feedback input, air amplifier input for remote sensing of the output voltage, and that's why when you're putting a resistor to it, you can make it so that way the controller thinks it's actually using less voltage, so that way when you actually change the actual resistance on a potentiometer, it will actually change the actual voltage being supplied to the actual GPU, due to the fact that the controller itself is being tricked, going, oh my god, not enough voltage, raise it. But then there's only so far you can go, because the controller itself actually has ILMF, CS comp. CS comp, not really, again, current sense, again, this is another one that you have to worry about. CS ref can't do anything really with it with the feedback mod either. Again, something I thought of, does not work, guys. Pin 3 is bad. Current only. Yeah, but yeah, so here, current sense, current CS ref, current sense reference voltage input. The voltage on this pin is used as reference for the current sense amplifier and power good of crowbar functions. This pin should be connected to the common point of the output inductors. Does not do anything for feedback mod. CS comp, again, it's basically like CS ref, but it's a little bit different. It's current sense compensation point. A resistor and capacitor from this point to CS sum determines the gain of the current sense amplifier and the positioning loop response time. This does not do anything to help a feedback mod. This kind of does. But then this is kind of pointless to do, just due to the fact, I'll tell you about it later, current sense and limiting scale pin. An existing resistor from this pin to CS comp sets an internal current sensing signal for current limit and I'm on. This value can be overwritten using the SM bus interface. Now that's those two pins. Some people are asking me, that's those two pins there. So that way you can switch the code and change the actual max current and all that as well. And they can also change the vid, and then you can do a lot, actually. You can change a lot on it with the SM bus. I don't have it. I don't have a connector for that to my computer, so I can't do that. And I like hard modding, and I want to learn some more about this kind of stuff. Now, pins 40 to 47, vid 7 to vid 0. Voltage identification DAC inputs. These 8 pins are pulled down to ground, okay? They're pulled down to ground, which makes them a 0, providing a logic 0 if left open. When in normal operation mode, the DAC output programs of FB regulation voltage from 0.375 volts to 1.6 volts. Now, again, they pulls them down to ground, but then if you put these to a power source, pin 7 to vid 0, but then we can check out down below. There we go. There we go. These are the actual codes for the NCP4206 for the actual vid. Vid 0, sorry, I guess vid 0 is one. Vid 0 and vid 7. 7 through 0. 7 through 0, or if you do it other ways, it's vid 0 through to 7. And then how you actually put these sequences for doing the switches can actually determine the actual voltage that you're actually getting. This, if you add vid again, just vid 0, just vid 0, out, off, nothing. Vid 0, off. Again, you don't worry about vid 0 just by itself. Vid 1 by itself, pulling it to high, gives you 1.6 volts. Very simple one to do. I mean, we're talking the simplest vid mod to do, but you're at 1.6 volts, and then you'd have to do a reverse feedback mod to lower the voltages, or else there's always going to be at 1.6 volts. That's simple. 1.5935 is vid 0 and vid 0 and vid 1. Now, to do something more what most people could do, 1.35 volts or 1.3 volts. Those are a little bit tricky. Again, I did a vid mod, and it gave me 8.85 volts, and it wouldn't even allow me to do anything. I couldn't get into the operating system or anything like that because not enough volts. Oh, sorry, 0.835 volts. Not enough volts. You need 0.855 volts to actually get a display. So, and then with the feedback mod, if you're starting off at that voltage, it's not gonna work for you. You want to be at a higher voltage, so that way when you use a feedback mod, you can control that voltage a little bit, so that way you're not hit, because you're still going to hit a limit with a feedback mod on a vid mod. There's still gonna be a limit. So at 1.35 volts with vid 1, vid 3, and vid 5, right? Saying that right? Vid 1, vid 3, vid 5? Yes. Vid 1, vid 3, and vid 5, right? You would have to do this in a sequence that actually works for it. Which means if you followed how Exaberry shows in his thing as well, you would not do it from vid 7 to vid 0. And then you have to do this in sequence. Given this power, 1. Given this power, puts it to a high. Given this power, gets it to a high. And you have to do the sequence to actually get the actual voltage that you want. If you don't do the appropriate sequence, as in giving the voltage or flipping the switch the appropriate way, you will not get 1.35. you can end up with getting something really low, a really low voltage. It could put you on to a really low voltage. So it's kind of annoying. It's kind of annoying to do. But I'll probably do. I might just do a 1.6 volt and then just do a reverse feedback mod just to lower the voltage and then be able to tune it whatever I want. And then we'll have to do testing on that as well to see if lowering with using a reverse feedback mod onto it, lowering the voltage a lot, if it actually causes issues as well, as in it puts it into a you hit an undervolt protection of sorts. We'll have to see if that's part of the thing too. Because doing the vid mod is, yeah, kind of annoying. Oh, is it a party? Yeah, I mean, it's pretty cool. Pretty cool how they did it. Gotta figure out where Excaberry's little handy dandy vid controller for the codes is. This is pretty simple actually to do. Just the way the actual layouts are for all this. How each one goes into another in a series, and then you can show with 10 kilo ohm resistors and 680s from the 680 ohm with a 12 volt source going into VCC comp 10K feedback. I switched mine over to no, I didn't use any. So feedback with the feedback here, 16 pin 16, and then trace it off to the actual resistor, which is a 10K. I just put that off and then put that to I try to get to a 100K resistor by adding two my pots together. It equaled out to 94 ohms, but kilo ohms, 94. It's good enough. Pretty close. It just makes it so that way the actual voltage right off the bat, if you have the potentiometers all the way up, makes it so that way it's a little bit lower voltage than what you would actually start off. Not a big deal. Raise up the potentiometer. Well, technically lower the potentiometer, lower the resistance. And then yeah, so pretty easy. Pretty easy. As you can see, it has a 100 NF capacitor, 39 kilo ohm, 1 kilo ohm, 1 volt, all going from NCP, 12 volt source, going through VCC, to C's comp, blah, blah, blah. We go over to here, we go straight down, and then we can go over into a negative or CS ref into a positive, and then we got ground. Why? As we gotta. And then also LMNF goes over to CS sum with a 20 kilo ohm and a 100 nanofarad capacitor. So that's those little tiny capacitors. I'm pretty sure they're 0402s or something like that. Pretty sure that's what they're called. Little tiny capacitors right here. Transform, flip the screen, there we go. The little guys here, 0402s, I believe these are called, these little SMDs. And then we got capacitor from ILIMFS, which again is for current protection, part of current protection. And then it just goes over. I raised up the ILMF as well. I gave it a higher resistance. From 7.2, that was on the actual The actual board, this is just what they're saying, that you could use a 10 kilo ohm. It has a 7.2. I raised it to a 9.38-ish. Around there is what my multimeter read, so I raised it to that. And it's not a 10. It was not a 10 that's on it. At least that's what I read. And then, yeah, FB is, yeah, these are all linked up together anyways. I didn't change it. Actually, well, I did. I actually lost the 1 kilo ohm. I just replaced it with a 10 kilo ohm. It doesn't change anything, though. I could have changed it with a 1 kilo ohm, but I just put a 10 kilo ohm. It doesn't do anything, though. It's still a perfect 1 or 10 or 100. This is a capacitor, though, NF. Capacitor in between CS sum and CS comp and ILIMIFS, which is part of, again, for currents. Which is I. It's I. It's I. Yeah, I don't care about that. Don't care too much about that. And then there's a bunch of, I should go over. Oh, I guess I didn't. Wasn't showing what I was talking about there. And then yeah, there's a bunch of math formulas that you could apply to figure out what you're doing for actually getting the readings that you want. So again, that's why I used a 9.3, roughly a 9.3. I wanted a 9.2 from going from 7.2 to a 9.2, but I couldn't find one, so I used a 9.3, so close enough. It just slightly raises the actual amperage tolerance anyways. I don't think I'm going to pass that kind of amperage on this board, so it's not really a big deal. But just with the feedback mod and doing a lot of capacitors, aluminum caps, and then also low ESR caps. Not these ones. Not all of them. Not at least not all of them, but a lot of them. Not this one. Not the brown one. I wouldn't really recommend it. But the better the cap. The better the cap, the better. I did read there's a bunch of other things I could apply to it as well. It's just I don't think it's really a necessity for this card. Probably not. That's not bad. Again, it gave me a good performance just with the feedback mod. It was fairly simple. The soldering, again, it's, you gotta have a steady hand. That's about it. Not too difficult. Steady hand. I did it all without a magnifier or anything like that too. Just my bare eyes. Although again, I did lose a couple of the really small, because I tried to use. I was going on their persona. So okay, well you can't even see it. Somewhat. I think we can see it, right? Focus, you. Focus. Focus. Alright. Maybe it's not gonna focus. But if you have a steady hand and you got some pretty good, you're pretty good at soldering, it's not that difficult to do, right? In theory. What I do. Go. There we go. You can see it. There's we got solder 2. And you gotta make sure when you're soldering to it that you're soldering it appropriately so that way you're not pulling off the pad. But all in all, it was pretty good. Pretty good performance for just a feedback mod. Again, feedback mod, you are going to have to worry about a overcurrent protection and over voltage protection. Those are two things you're going to have to worry about. Unfortunately, there's no getting. I mean, over current protection, there is a way to get around that. The over voltage protection, there is no actual way to get around that unless you just do a vid mod. Unfortunately, and I've been trying to come up with ways that might work. There isn't actually one that actually works. From reading onto forums, doing my own kind of theories onto it as well, and then I applied some theories. It doesn't, none of those theories work. Capacitors help a lot for the transient spikes, but for doing certain benches, you still can only go up to 1.26 volts for certain benches. I mean, it gives you more voltage, yeah, but then other benches you're good for up to 1.36 volts, and then one bench that I've tested, well, actually do almost 1.4 volts on some couple benches, but on one bench you can do as much voltage as you want, and it's not a technical 3D benchmark. It's what people are, I guess, calling it. I call it a 2D. It's not a 2D. It's a 2.5D because it is on graphics card. It's still technically a 3D benchmark. Any GPU benchmark is a 3D benchmark is how they're classifying it. I don't know who the fuck came up with these rules with the classifications on benches. This is the stupidest fucking thing I've ever heard. Oh, because it's on a graphics card, it's automatically a 3D. I guess. I mean, if it's not actually giving you an actual source of, like, video output other than some, like, the code, like the actual numbers, it's just giving you numbers. Okay, well, how is that a 3D benchmark? I guess it's a 3D benchmark, but some people are calling it 2.5D. I thought that was pretty funny. 2.5D benchmark. I'm still gonna call it a 2D benchmark because it's that very simplified. It's all about math. Oh, just because it's done on the GPU, who fucking cares? It's still a 2D benchmark. It's not actually outputting an image. It's already, well, technically it's outputting an image still. Just turn it on your PC with a graphics card, it's outputting an image. So technically, I guess technically it is a 3D. I mean, kind of dumb. Still kind of dumb. Yeah, the feedback mod was good. It was good. I just wish there was other ways around certain limitations just with hard mods, not with SM bus to change some code. And yeah, I wish there was. I mean, if you had a certain graphics card, a certain graphics card, you could do whatever with a classified. You have to have a EVGA classified though. You have to have a fucking classified. It's gotta be a classified. I don't have a classified. I have an SC. Okay, it was really cheap. The classified, they actually have software though. Again, it's software. I know. It's dumb. There should always be a way to hard mod something to do it the way you want it to do. Yeah, it's not even like, I guess I could do a Frankenstein card too out of that. I could actually do an E-Power, but I need to somehow make some actual money so that way I can buy dead graphics cards, A, fix up whatever I can actually fix up, and B, actually make some E-Power boards out of them. Like some old 480s, GTX 480s, GTX 580s. 480s and 580s are really good ones to do E-Power boards from. Very, not too difficult to do, actually. Not difficult to do at all. I would like to be able to buy a bunch of them. Fix up whatever I can, and then cut up the other ones and make them into E-Power boards. So that way I can do an E-Power GTX 770 if I wanted. Although, I would not do it on that one. This is technically a working card. On a lot of cards that are something's wrong, like seriously wrong with them, and you just don't want to fix them up, just E-Power them, boom. That's all you gotta do. But it is what it is. That's, again, that's like a very, very simple mod to do for voltage. And it only works for, I mean, it works for all benches to give you more voltage. But like I said, 3D Mark 06, terrible. Skydiver, it's still terrible. For some reason, 3D Mark 11 entry, terrible. Those three benches were horrible. 3D Mark 03 was a little bit of a pain in the butt too, but after it's okay with the one capacitor. I mean, it ran a lot better. But 3D Mark 06, holy crap. Oh, if I do more than 1.26 volts, it just craps the bed. It just craps the bed. Does not, nope. Just turns right off. Nope. Nope. No more. It's still good, because when I do chilled, it's still going to give me more voltage, give me more frequency. I'm hoping for most of these benchmarks for even the legacies. I 2000 Mark, 3D Mark 2001 SE, I can already do quite a bit of voltage onto it. I can already do 1.4 gigahertz plus onto it, so it's not bad. But for the other legacy benchmarks, I'm hoping to run 1.4 gigahertz on all of them. 1.4 minimum. For GPU Pi, I'm hoping to get up to 1.6 gigahertz, which would be sick. Would be sick to do 1.6 gigahertz. Because again, I can do as much voltage as I want. I actually limited myself to how much voltage I put into it, because yeah, I can do as much as I want. It doesn't care. It does not care on that bench about voltage. The card doesn't care. That's what I'm talking about. The card. Again, it's some weird over voltage protection that just does not make sense. On GPU Pi, as much voltage as I want, it will do it. It's for the legacy benchmarks. As soon as you start going into those benchmarks, for some reason, just no. Time Spy is not bad. Fire Strike's not bad. We should try it out for gaming. Like I said, I'm probably gonna put it on the face plate, the front face plate that cools the memory and the VRMs and all that, and put it back on the air cooler. Probably put it back on the air cooler with the feedback mod, the voltage mod onto it, and all the extra capacitors, and then maybe we'll run some games, see how good it runs some games. Then I'll search up the old CS2 game, CS2 runs that we did, and see how much better. Voltage is courage. I mean, man, GPU Pi, when I said as much voltage as I wanted, it would allow me to do as much voltage as I wanted with just a feedback mod. And a lot of things just don't make sense. If that benchmark allows me to do 1.5 fucking volts, how come with these legacy benchmarks, these older benchmarks, only allow me to do 1.26 before it shits the bed? Just shits the bed. I mean, we're talking no OC. If it's just a 1 millivolt higher, 1.26, it just shits the bed. But then other benchmarks, no problem for more voltage. And again, 1.5 volts on a GPU Pi. How in the does it work on that, but it doesn't work on these? Is it just the benchmarks? No, it's the vid. It's the vid, man. It's the vid. The vid is causing the issue. So doing a vid mod is going to be the mod to do. Unfortunate. I mean, it is what it is. It really is what it is. It is what it is, guys. It is what it is. And then I will do a vid. I'm going to be doing a vid mod. I just don't have the money. And money is going to be very tight because I got paid very little this month. And I'm not going to get paid next month. So Yeah. Not sure how that's gonna work. I made very little this month, and I don't get paid next month. So I have to plan for this month coming up. Not this month, because I get paid whatever I made this month, technically, or last month, technically here soon, and then I don't get paid for this month next month, if that makes sense. So I have to plan for next month, not this month coming up. Well, actually, this month coming up, yeah, for the whole month. I gotta figure out what to do. I don't know. We'll see. I know what I'm gonna do is get Gowie a big bag of FOOD. Get her a real big bag that should be good for a long time. And then I don't have to worry about her. I already got her tons of litter as well, so she's good for that. And then I don't have to worry for a while that way. Just a guarantee. Yeah. And then, yeah, I don't think I'll be able to do the vid mod anytime soon. And I probably won't be able to finish. It's actually right there. I probably won't be able to finish the. Oh, it's right here. Sorry. I won't be able to finish this month. I won't be able to get the parts either. That's not the issues there, Persona. The DirectX 9, 10, 11, and 12 are not correlated to the actual controllers that are on the board. You'll have to find out depending on the model of, and it depends on the model. Not all, let's say not all GTX 770s have. No, I started soldering on small stuff. Well, technically no. I guess I started soldering technically doing a little bit of copper roofing, and then did some plumbing, light plumbing as well. Did soldering on light plumbing. Um, I've always been good at brazing and stuff like that. So getting into soldering itself, I went right into doing small soldering. It wasn't that hard for me to do. Just it's more or less. It's not even about having good hardware. It's about having steady hand, knowing what proper tips to use. The tips that you actually use matter. I thought this was a 100-watt solder iron. It's actually only a 60-watt. And yeah, it's ESD safe. It's I have this in videos. Check it out. Click the affiliate link as well. It helps me out as well. This soldering in hot station, it's not that good. It's pretty good though. I mean, it's pretty good. It comes with extra heater for the soldering iron. Comes with extra heater coil for the actual, and they work great. 600-watt hot air. I mean, it works really good. I can show how quickly it heats stuff up, and you can start desoldering stuff. But yeah, just having a nice steady hand. I don't even use a magnifying glass, man. I don't use any magnifying glass. I don't use any fancy machines. Oh my god, I'm so blind. I gotta. But no, it's steady hand, lining stuff up properly to the pads, prepping the pads, using. Again, I like to recommend it. 8341 no clean flux. Using good soldering flux for what you're doing helps a lot. A lot. Now, solder it well as well, depending on the solder you use, can actually benefit you as well. Taking proper care of your tips is very beneficial. Again, different kind of solder depending on the job, more beneficial. Flux is your friend. Flux. And we can show off the card. Oh, people always say, like, whatever they want on how they solder and that too. I don't think I'm the greatest, but I'm definitely not the worst. See how nice shiny little tips we got there? And we got doubled up. These ones are doubled up. They're really high because they're doubled up. And then I gotta clean up the board. See, we still got flux. That's why I didn't really want to show it off, because the board doesn't look good with all the flux still around. But I'm just gonna leave the flux just in case I want to add more caps to it. Again, I do want to add more caps to the VRMs here on the back. I can't really add them to the front. Can't really add them to the front because I would well, I guess I could. No, I can only add it to the one for a lot of them. I can only do a side cap onto the one, and then I can't double it up just due to the fact the way the front plate works onto it. Then all the core here, the core, same thing. Could be a little bit straighter on that one, but as you can see, the soldering's pretty good. These were quickly done. These to me look terrible. This is with so this one, and I'll probably redo this one with that later on because I'd rather use, this is an epoxy style, epoxy coated wire. So all you do is you just strip the one end of the epoxy with A, sandpaper, or B, just use a knife and scrape the tip. Scrape away the epoxy coating. Or you can just sit there and hold the heat to it and eventually it'll melt the epoxy off, but it's likely not to do that. It takes a long time. I did that more or less because there's coating on that. Again, epoxy coating, just in case I do set this card down, right? I do set the card down. Sorry, this way, set the card down on something, and then I don't have to worry about the cap or something like that pushing up and then the actual wire touch anything, because if it touches anything, it's not going to make a short anywhere. That's why I did that. And these are actually wires. 16 gauge wire. No, sorry, 18 gauge wire. Sorry, 18 gauge wire. Just for flexibility more or less. And this right here is a bit stiffer. This is wire, fully tinned wire, but this is not in the way of touching anything, and it's stiff, so it's not going to move anywhere if it has some sort of flexibility. Just because I fully tinned it. This is terrible, by the way. This is terrible. This is just a quick job. And then let's just solder it onto the caps, onto the core. The big caps to the core. Fairly easy. And then, yep, there we go. We can show this wire here. Again, this is for voltage readout. Voltage readout. I can literally like hang the card off of that if I want. I just want to be careful because I don't want to pull anything off. If you pull anything off, you will pull the pads with it. Then I will be doing all these memory capacitors as well. And fairly easy to read on this board. I love how everything that is silk screened on, C, anything that starts with a C is a cap. C. Even though a lot of these, like 90% of these I added on. I added literally 90% of these caps on the back. And that helped a lot from the VRM. It helped a lot. Very, very impressed on the performance just doing that. Doubled up and adding on to, so like this one right here. This one right here had nothing on it. So there's nothing on it, nothing on it. I am kind of picky on making things a little more even in ways. So I even did this side of the VRM and this side. So this phase and this phase basically of the VRMs. I think it's a double up 3. So there's 3. Yeah, double up 3 is what they call this. 3-phase VRM. So we got 2. So this is for this 3, and this is for this 3. And I put on literally 90% of these, and I'll add, when I get more 22 NF, 22 microfarad capacitors, these little ceramic capacitors, I will add on, and then maybe double up every single one. It takes so long to desolder them. Check with multimeter, desolder them. So what I'm probably going to do is just desolder a whole board, and whole motherboard, the rest of that motherboard, everything I can get off of it, desolder it, multimeter it all up, put it off to the side. I gotta figure out where all my little baggies are still from the move. I still haven't done unpacked and everything, so I'll have to find out where my other baggies are so I can put the more capacitors in where the certain capacitors go, where certain little actual ceramic capacitors go as well. Any MOSFETs that I take off, any little 1.3 switchboards. Not sure what else I can really. Oh yeah, I guess a bunch of resistors. Yeah, I gotta through all the resistors. Oh my god, there's so many different kind of resistors. I don't have enough baggies for all the different kind of resistors. So I'll probably just do a bag of resistor and just be like, well, this is close to this is close to that kind of thing, or just test before use kind of thing. But it is what it is. Yeah. Capacitors, again, not these ones. It's hard to show. Pretty good soldering on the capacitors as well. Adding them on to the back of these ones here. So these capacitors here. And then with these ones here, I added on to the back. You just go over the same polarity. Blue side out, positive. Blue side out, positive. Easy peasy, lemon squeezy. And then I did not add back in that capacitor because every time I added a capacitor, there's something wrong with this board onto this actual capacitor, wherever this one goes to. For some reason, it keeps blowing capacitors, so I just left that off. Everything works the way it should. And then having the extra capacitors anyways on top of these three, so doubled up on this from power source. Good to go. Thumbs up. Yep, that's good. And then wherever I can add a capacitor, again, I'll add on for these VRMs here. These two. Well, it's these two, and then underneath here, ta-da, another one. And then we got these two over here. I'll probably add caps to as well. I would like a bunch of 47s, some 47 microfarad capacitors, which would technically fit on those. They would fit on top perfectly. I could do that. And then I still got to do the memory chips. Adding capacitors to the memory chips should help me get a bit more performance out of them too. Yeah. And then once I get everything all soldered up, I'll do an ISO wash whenever I get the ISO profile. Except for ISO profile, I have to buy it by a lot, and it's not cheap. So that might be pushed off way later. Until then, it's fine having a little bit of flux on the board. Not going to hurt anything at all. Especially when you're using, again, 8341, no clean flux. You don't actually have to worry about it. You don't have to worry about it. Other kind of fluxes can actually corrode things. A lot of people don't know. That's why I recommend 8341. It's made for electronics. EA, it's in the game. Wait, is that how it goes? Oh yeah, I guess I could add actual more caps right here. I could actually add more caps. I would want to use SMD caps too, though, which I don't have any of them. I actually don't have any of them. And then for voltage readout, the voltage readout here, right? You could go off of one of these little guys, but go to a bigger one for safety reasons, as in you can put a little more strain onto it and all that. You don't have to worry about ripping it off the board, right? That's one thing I put it on that one. And then you could also read off of VRM as well. But the VRM is VRM voltage. There will be droop. This board has a little bit of a droop from VRM to the actual core. It's very little. And then with actually all these extra capacitors that I added onto it, it's even smaller from VRM to core, which is really nice as well. And then core being closest to the GPU core for voltage readout is the best. So this is positive, and then whatever ground. So through holes work good for grounds, or you could solder onto the actual board wherever you want, onto the same capacitor basically technically, but I just use a through hole, put the actual multimeter to it, and that works. But yeah, I didn't really start with big stuff. I started with the small stuff. Grab yourself dead motherboards. Grab yourself again, if you go into my videos for the stuff and click the affiliate links, it helps me out. Plus, it's fairly cheap and it works really good. Like is it like a fluke? No. Is it close to a fluke as in for readings? Yes, it's actually very close. It's not far off. Plus, you can do voltage readout, DC, AC, ohms, capacitors, hertz duty cycles, and then a whole bunch of other ones that you want to read. I'm pretty sure this is for actual amperage. Yes, amperage. There it is. And then what we'll actually have to do range select. Oh, min max. There we go. Max. And I don't want to plug it into the wall. And back off. But yeah, yes, the Astro AI DM6000 AR. Yes, so with this one here, with this, I can get clamp attachments. You can actually get clamp attachments. I can't find them. That's why I actually got this one, because you can actually get clamp attachments for wattage. You can do amperage. You can still do amperage without clamps. I wanted it for wattage. For wattage. And you can get clamp that you actually hook in like the same way. Clamps. Watts. For wattage. So you put around like a GPU plug-in, and it'll actually read the wattage. Or you put around a plug of some sort, it will actually read the wattage. Yeah. Crazy, right? But how is it getting the voltage and the amperage through a clamp? Well, the clamp amp, but yeah. Yeah, buddy. I can't find. Yeah, you just set basically the voltage that it's doing, and then it'll do the amperage, and then it'll get the wattage for you off of the voltage and amperage. It does all the hard thinking and math for you. Yep. I can't find them. I can't find the clamp. There's actually a clamp attachment. We're not talking alligator clamps. We're talking like a clamp, like as in for like amperage clamps that you would find on other multimeters of sorts. There's actually attachments for this unit. I just can't find them. Amazon does not sell them that I know of. I can't find it on Amazon. I would like to get more tips. Actually, I'll probably just get a whole other multimeter, so that way I can do multiple readouts and then get more tips as well, so that way I can modify the tips. Probably take the tips as well, cut them, splice them, and then actually like make my own tips, so that way I can make my own hookups. So that way there's like solid connection to whatever I want. Just make things a little bit nicer for me. But maybe, I don't know, try to be able to save up money for an oscilloscope would be nice, but that's in the future. And is an oscilloscope really gonna give you any beneficial gains for doing this? No, it's not technically. Oh, but transient spikes. Okay, yeah. Well, who fucking cares? You already know it's gonna have everything has a transient spike, so you're gonna take every measurement that you can, every measure to make it actually so that way there's less of it. Capacitors, decouplers, a lot of different ways to actually help with transient spikes. Would you do that anyways? Yeah. Well, guess what? Then where'd the oscilloscope come in handy? Tell me where the oscilloscope actually helped you. Oh, but it's more accurate. Maybe on the newer GPUs. We're talking a lot newer GPU. Like we're talking like 30 series and up GPUs. Maybe it's a little bit of a factor, but there's always going to be transient spikes in everything. There's nothing you can't get around it. So even being perfectly accurate with your readings is still not going to be more beneficial than actually doing certain works and workarounds on certain GPUs to make them better. And you're always going to do it anyways because you want to get the most performance generally, or the smoothest or more efficient GPU that you can. That's why you add a lot of capacitors, certain capacitors. Again, capacitors, decouplers if you wanted to as well, but just capacitors. From power source to VRM to the core. It's one of the best ways to do it. Smooth power source in, smooth power source to VRMs, which means VRMs can give smoother power source. Hmm. All in all, though, not bad. It's a lot of testing I did though, just to see, and a lot of theories. I did a lot of theories and then applied a bunch of theories, and then it does not do anything just due to the fact the vid takes over on a lot of things and then it automatically trips whatever it's going to trip. Which really sucks. It actually really sucks. That no matter what I do for hard mod with this controller, just automatically will, nope, don't care. Don't care. And maybe because the GPU pi is always at a high, it never drops down or switches to different boosts and that for different boosts and also different voltages. So there's not any switch back, switch up, switch back, switch up. And then I should show, maybe tomorrow I'll show the actual feedback mod in work, and I'll actually show on the multimeter how much the actual voltage changes. Like we're talking a lot. Like it just goes up, and then for certain portions of the test, down, up, down, up, down, up, down, power off or no, full frequency, no power load onto it, voltage goes way up, back down to power, full load onto it, power goes down a bit more, and then it goes up and down throughout the whole test. Like through one graphics test, the voltage just goes up and down, up and down, up and down, and that's not because of transit spikes at all. That's actually because of the boosts. That's the boost in play, as in the actual core clock is not always up. The core clock's never always 100% up, no matter what benchmark you're doing besides GPU Pi. Technically, the actual core clock is not 100% up. It goes down, up, down, up, down, down, up. No power, more, nor no on load, no load. Power goes up, no. It's like wild how much it actually changes. I didn't think it would be that much of a fluctuation throughout the benches, and it's every bench except for one. So, and then we got these other benchmarks that are completely just terribly optimized, more or less. So transient spikes are gonna be way worse on certain benchmarks. So I get where maybe a trip of over voltage protection would happen, just due to the fact it's up down up down up down. Oh, okay, well it's since the switching frequency is not fast enough, it's boom, all of a sudden the transient spike is at a high when it should actually already be at a low where the actual boost is at. So it's actually way higher than what it's actually reading at, just due to the fact the spikeage actually was a delayed spike to at the point of time of where the actual boost was at a low. So the voltage should have been way lower, but the transient spike that was already was up at a high is going already 100 millivolts to, we'll say, yeah, 100 millivolts. We'll say 100 millivolts because even at 100 millivolts that's a lot. Some people are saying 200 millivolts. It's kind of wild seeing a 200 millivolt transient spike, but I mean, yeah. I mean, with all these capacitors that add on too, I don't think there's not much of a voltage transient spike there, but good. But yeah, let's say because it's delayed, the transit spike's really high already while it's at full low, so at 1.3 volts, and then add on another 100 millivolts, so 1.4 volts with the transient spike. Then what's going to happen is, since it's already at a low, and then we had that delay coming in, there's that transient spike that's already high, and this is already dropped down to low. Well, we're already 400 millivolts higher where we should be. So, well, over voltage protection kicks in. That's the only way that can happen, and that's because of a delay to the actual controller reading that. So stupid, just stupid. And I don't know if I could do some sort of decoupling capacitor of some sort, if that would actually be more beneficial or not. Not sure. But I'm probably gonna end the stream. I'll be back though. Yeah, I'm ending the stream. Probably gonna stop streaming here, actually. I won't be on for a while. If I even stream again. Streams are just brutal. I was gonna do that tomorrow's stream. Have a dual PC set up. I mean, I have a PC I could set up right now. It's got a cool 3770K's got a cooler on it. I got no way of showing the actual. I don't have multiple webcams in that, so I can't really show it working, right? Show everything. I can't just do it. I can't do everything that people actually have money to do. I don't know. Nobody actually cares, to be honest, so. How am I going to show the multimeter hooked up to it for the voltages? How am I supposed to show the card that I'm actually showing? Could just show the card like every other dumb YouTuber that does that. Doesn't show their face or anything like that, or show. I could just set it up. So that way you can see. I could show the card working. You don't see the you can't see the voltages unless you have a multimeter hooked up to it. It just shows max of 1.212 volts. That's it. Can't use software. With no power limit mod, you can't even see the wattage because I have no power limit mod on it. So you can't even see the wattage. And then if I get rid of the no power limit mod so you could see the wattage, I'm gonna go past the wattage and it's just gonna crash anyways. Although I have a no, because it'll talk to that controller, and then yeah, that controller probably override what I have done with the one mod I did for the feedback mod. So yeah. Why, you want to see some runs of the card? I mean, it's not like you get to see anything fancy. It's just it's not like I'm gonna be beating my scores that I already have because it's gonna be with the 3770K. So I don't see a actual point really to do it. No one really knows about the GTX 770. That you can only do like plus 50 megahertz, or yeah, plus 50 megahertz, or maybe plus 75 max. Just because I can do plus 100, plus 200, or plus 300, or plus 400 on certain benches doesn't exactly show what it's doing. How much voltage I'm putting into it. Should just start making videos, and that's about it. Well, I could set it up. Just take me a second to set it up, and then set the multimeter to it so I can check out the voltages. I could. If you want to give me a second, I can get the other PC up and running. Morning, Beth. I'm just setting up PC right now. Well, happy B-Day. Alright. Need to do add a capture device. Boom. Mm, 0.911 volts right now. Need the other keyboard for this. What? It's only green because of the GPU needs to have a driver on older stuff. Really? I shouldn't have an issue. I might have to redo this. I'm not sure what's going on here. Oh. Apparently I unplugged the headset. I'm like, man, what's going on? What's going on? Well, you'd help if there was an SSD installed. That should work now. It's like what? Yeah, whatever. I don't care about CPU fan matter. Let's go here. Monitor. We don't care about CPU fan speed. Ignore. Been pretty good. Got a few good scores put up. Nice. How's that going? You gotta have to give it a minute for the driver to load. I don't have to plug it in. I think it's in this data bank. No, it's not. It's not in the data bank. Come on. It's like it's working on it. It's working on it. I never checked on how you explained it to Ducky. I didn't read that part. Cause you got career, and you got season. You got overall global masters, hardware masters. Career, you got more hardware and global points or runs, best CPUs and GPUs or whatever, RAM as well for that. And then season is the basically the same as your career, but per season, and then it's less hardware points and less global points. It's not really less, but it's only so many valids can be put in to get you so many points. Less, basically. Taking a sweet time. 10%. Come on. Why is it so slow? It's taking its sweet time. Really. Nope. Not sure where I put the Wi-Fi. Apparently back up there. Oop, yeah, no. Yada yada. She's sleeping. She's tired. Nice. Holy crap, man. It's actually wild. It's just a feedback mod. It's just tricking the controller into thinking it's using less voltage than what it actually is. So you can put more voltage into it. It's not the best mod to do. It's a good mod to do with another mod, though, which I will be doing whenever I get the money to do it. This is all free for me to do. Kind of my price point. No driver. Not sure. Yep. This should be the last one for it. It's not downloading. There we go. 20 minutes, 15 minutes. Oh, I think it would be faster than that. Let's go. I got a better idea. Restart. should be faster. The most demanding benchmarking software. You got a high five, honey? I called it. I called it, man. I called it. Now it should, in theory. Yeah, Furmark's just brutal. Yeah, Furmark. Oh, come on. Really? I have to do it the other way? It's not it's just not gonna do it? It's seriously just not gonna do it. My God. Oh my God. No. It's just being so slow. It's a bit faster now. That's good. Oh, 45 minutes. Oh my God. Maybe. AMD sponsors Ferrari? What? TV second. Maybe a fan on the CPU would actually keep it warm or cool. Keep it warm. It's definitely warm. Might help. AMD sponsored Ferrari. It's different. Oh, still saying it's taking forever. It's really annoying. Yeah, I do have it set for streaming, so it's technically uh, not for download speed, it's for upload speed. Huh. Some weird Asian lady at a major car race. AMD CEO. More like a millionaire. Just another millionaire at a car show. A race, sorry. Boom! Put it for download speed instead of upload speed. It goes a bit faster. I had it set for when I use a streaming PC. No. Welcome back. I had it set for upload speed, not download speed. There's certain... No, there's no way to do that. Again, it's not... There's settings for your Wi-Fi if you know anything about your internet, that you can actually get really fast speeds with Wi-Fi. Oh, continue. Hurry up. Yeah, and then I had it set for upload speed because I was using it as a streaming PC. There we go. Boom. Oh my god, let's go. Yeah. And then the download speed probably was close to like maybe a megabit per, not even a megabit per second. Oh my god, and now we got color. I used to have my own internet, 1 gigabyte download and 500 megabits per second up. Yeah, definitely won't. Or will it? Yeah, let's go. Actually, yeah. Do we even need that now? No, cancel. We don't even need that now. Swim by the beach of the bush. MSI. 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 Oh, I have to download MSI. Off. Oh yeah. Yeah, if you don't have it optimized for upload speed, your upload speed would be like 1 megabit per second generally on Wi-Fi. I can get 75 megabits per second upload speed, which I can do 4K streaming at that. Final. The antelope? Yeah. Antelope would. It would. I agree. Oh, that's not even an antelope, but it does. Ooh, I don't want rivet tuner. That was a closey. No, no. No, I didn't make a vid on it. I will make a vid on it. I should have made a vid on it, but I was trying to I wanted to get the way I was doing it was I was doing tests, so just regular tests with just the feedback mod, which you don't know how many hours of benchmarks there is to do these tests. Like it's a crazy amount. I barely got any sleep over the past what 3-4 days. I'm talking. I've been up since yesterday at like around 9 p.m. I've already been up for 11 hours. No, 13 hours. I've already been up for 13 hours. Yep, GTX 770 right here. All right. Core voltage. It says 9.75. It's at 1.016 right now. And we'll do this. We'll probably only do 500 because there's no fan on it right now. On memory, core. Oh, we want to do plus 300. Yeah, you do. You gotta put in the work. So minimize this. Have to stream too. I mean, have to make money somehow, right? Wait, we'll see what we can pass right now at low voltage. Probably do like maybe plus 235, 235 on the core right now. Not very high voltage. No, see, that's the thing. I did all those tests with just the feedback mod, and then I did test for just certain capacitors, and then I just did test on more capacitors so capacitors from the power in, capacitors to the VRM, capacitors on the core, more capacitors on VRM for the core, more capacitors on the core, and then I also changed out resistors for helping trick the actual NCP4206 controller to make it so that way I wasn't hitting over current protection, which worked, but the over voltage protection is a different part because it's part of a vid, and that's completely different. So feedback mod, you can only do so much. Now I'm gonna raise the voltage here. See, okay? So we failed. We're at 1.4 gigahertz. We failed. I can even do it again, right? I'll do it again. We'll fail again here because 1.4 gigahertz. No, I'm out of coffee, and yeah, it is what it is. Oh, we're passing? Oh, what? It's doing it. It's doing it, guys. It's gonna fail. It's not gonna pass, but I mean, we're only at 1.25 volts right now. It says, so in the top there, it says 1.212. On load, that 1.212 would be at 1.2 volts, maybe on load, maybe less, 1.29 volts or 1.9 volts is what it'd actually be at. I'm at 1.25 volts right now. We're passing. I didn't even change anything. I didn't even change the voltage. We passed. Okay, we'll do plus 320. 320 on the core. It will 100% not pass now. 100% not pass now. It's like, nope. Ba-ding. Yeah, so that's how hard of a crash it is with not enough voltage. So open it up again here. We'll make sure this is good. Let me put some voltage in. Alright, we're now going to be at what voltage? I'm not sure what we're going to be at right now. Okay, stop. Stop. We're not. We're not. Stop. Boop. Actually, we can just put that down because we only need that. There we go. That should set it now. Calculate and go. 1.489 at 1.28 volts right now. So we're passing a little bit. I don't think we're going to pass. At 1.283, I don't think it passes. Yeah, no. We need to be like 1 point, from testing, 1.325-ish. Right around there would be good. Just because we have to restart every time, because when we do these hard crashes, it won't allow me to do it, so I have to restart it each time. 1.305 volts now on load. 1.305, 1.489. Ooh, do not like that. I told you it needs a little more. It's right around 1.325, 1.3 volts for doing this, just from testing. I think we ran 1.31 volts at 1270 on air. 1270 is nothing. I'm at 1.4. I'm almost at 1.5. It's only a feedback mod. Yeah. Max I was able to do with feedback mod on GPU Pi is 1.465, and that's, I didn't want to go any higher with voltage. I could technically go higher. 1.33 volts should pass. Nope. It's not gonna pass. It needs more. Brutal. On air? So that's the thing. What was nuts and bolts? Was he doing chilled air or something like that? Because there's no way he did 1.54 gigahertz. 1.45 gigahertz on air on the same cooler I have. And then he has another picture of a Sapphire card, which doesn't even make sense. But I know he was using the EVJ SC model, like I have. There's no way he was feeding it fucking LN2 air. Guaranteed. There's no way he did that on air. Guaranteed. Was he even GPU Pi on 3D benchmark, like a 3D mark? 3D mark. $1.338-ish. Yeah, still says no. We'll recalculate. I think we'll have to restart though. Oh no, we're good. Oh, it's not applying. As you can see, the voltage up top there is not applying it. Should be saying 1.212, but it's not applying it. No, nuts and bolts literally is the only one up by LN2 scores. Okay, I think he had the AVJ classified too. Sorry, I think he had the EVJ classified. Up by LN2 scores on air. It's like, why is it not applying the voltage perimeter there? Do I have to reset it too? I don't know why it glitches. It's glitching. I mean, it doesn't really matter. I have Oh, that's probably why. I didn't realize we're at 1.5. I didn't think 320 was 1.5. We are gonna need a bit more voltage for 1.5. No, he was. It's not GPU Pi he was on. It's not GPU Pi. He was on 3D Mark. Shoot, what was it? I don't think it was Time Spy. No. Is it Cloudgate? Might have been Cloudgate. Another one. He definitely had some really cold air. 20 degrees ambient or idle temp, 57 degrees Celsius max temp at 1.45 gigahertz. It's like, nah, man, I would love to believe it that you're, but nah, it's not possible. Dang, this is actually would be a really good run. Yeah, yeah, exactly. Yeah, he was close to. I didn't even check to see what voltage we're at. Well, we should be around there, almost 1.4 volts now. See how I'm on water? 37 degrees Celsius on water? Out of memory? What have you changed around to do that? Let me try it one more time. For some reason it's crashing. I'm not sure why. Oh! VRMs are getting a little warm. Whoops. I'm sorry, VRM. Yeah, VRMs and choked were a little warm. I'm not sure what that could be. You should definitely do like clear cache and all that crap too, and I don't think so. I think you have to manually do that, don't you? I know why we're crashing now. The VRMs were. I'm sorry, VRMs. I generally have it set up in a different PC. I just set it up. I forgot to put the fan on the VRMs. See, I'm on water. Water, 27 degrees Celsius right now. Water. And this block cools at 1080 Ti around 500 watts. I mean, easily does it. Yeah, 1.37 is not enough. 1.37 is not enough. Are not the VRMs cool enough? Google works fine. I have no issues with Google. Too much voltage. I'm not sure what I put it up to there. I think the VRM is just too warm too right now. Should have had a fan on them. Yeah, with feedback mod and the way the controller works and the way the vid works, just you can only go so far with the feedback mod. Although I should have been fine, it's more or less VRM's probably just a little too warm still. Should let them cool off. It's generally at 1.5. I need around 1.4. .4 volts. I've done testing around 1.46 volts and up a little bit. That's max. More or less quick test though. Well, I should do one run here on it's an hour-long benchmark though. It's just too warm right now. By the end of the run, it's gonna be so hot. Like an hour-long benchmark. Let's just do plus, I don't know, 260. We'll do 260. I don't know what that puts me up to again. Let's see. This one, but at 32 billion. 32 billion. 32 billion. I'm going to. I could probably get a team record actually for it. Oh, stop. Oh my god. There we go. I did. I want no over a little more. There you go. There we go. 1.437. 1.25 volts. I would love to know if you can use the classified on these cards. I don't think it is. I think you have to have a classified card. I'm pretty sure the controller on it's not the same either, so that's probably why. Oh, so close to passing. Stop. So close to pass. 46 seconds so far is the best I've done, but that's still not great. I'm not waking up the nugget. Let's do that again. Actually, a little bit higher, but we'll do... I think the RTX would do better. The RTX would do better. 1.261. Yeah, definitely the RTX would be more of a grill machine. Like even at higher voltages, it's still not terrible. The VRMs are getting cooler too, I think. Although the fan speed could be higher. Oh wait, I could do that. There we go. So now we got some airflow on. Oh yeah, of course they are. Of course they are. Oh, I was reading some old forums of like the GTX 680s. They're like, you should get this one here. It's only $600. And it's like the top of the line EVJ hydro copper version or water block, not even EVJ hydro copper. I don't think it was hydro copper, but it looked like one. Like water blocked, decked out. It's only $600. 48960. That's not bad. There we go. We passed at 1.45 gigahertz at 1.281 volts. The VRMs are starting to cool down. I'll let them cool down a bit more. And we'll try a little bit. Oh, I said a little bit more. Not a crazy amount. There we go. Yeah, I would love some 480s, 580s. Dead or working. I don't care. Whatever. Whatever I can use, basically. MSRP, $1,000. That's pretty good, right? MSRP. I mean, it's hard to beat MSRP nowadays. Should be around 1.3 volts, I think. They needed. Well, yeah. They did it for GPU scammers. Got to be a Prime member. Then you can only buy so many. Yeah, 1.3 volts right now. 1.46 gigahertz. 48.523. Now, I'm going to redo that, but I'm going to test it at 10M 128. Yeah, let cool down. VRMs are cooling down now, so that's good. Probably not giving the greatest voltage because they're so hot. Oh man, they were toasty. They were toasty, man. Where's Honey's reaching hand when you need it? No, man, you can watch the video and actually watch the video. I have the videos, multiple videos out there showing. If you like, I can remake a video. So it's all up to date for you, but I mean nothing has changed. To watch them again. I checked over your subs. You didn't do them proper. No, they don't. That was worse. 50 seconds. And yet some people, that was better for them. Depends on frequency, I've been noticing. Depends on the actual frequency you're running. It's going to be what actually determines your batch size and reduction size. It's kind of odd. Depends. It really depends. For what I've been testing around the frequency I'm at, 20M, 512 seems to be the best. I'll show you again. So that right there was 10M, 128. We'll do 20M, 512. Yeah, in the rules, yep. You can literally read the rules and look at the actual picture. The way I do it gives more information than what the rules suggest, so there's no way for them to actually say there's something wrong with the validation, because I give more information than what they actually want. Yep. Oh yeah, very easy to mess up. And some people just don't care for certain subs to do a proper validation. But when you're in top 20, if you're doing like getting top 20 scores, you have to have proper valid subs. For what GPU? 48 seconds. I would have had 48 if it passed. I can pass this, and it's not the VRM's cool enough. They're probably still not giving the best voltage. Yeah, so you actually watched my, well, yeah, yeah. Basically, you watched my video. 11.9 seconds. Should be around there. I think so. So if you watch my video, you won't have any issues for proper valid subs. And pretty sure, right, Persona, I did GPU and CPU both for URL, for even having URL, or I'm pretty sure I did multiple different ways for multiple different subs, right? I'm pretty sure. I did it pretty straightforward. Yeah, it's pretty straightforward. Then once you have that set up, and then once it's all set up from that one test system, whatever CPU, GPU, motherboard you have set up onto it, you can literally just click on reuse old sub, as in reuse the old settings, all the old same CPU, GPU, RAM, whatever they had saved previously from the other run, and even with the picture from the previous run, and all you have to put in is the URL, the screenshot, and literally your sub, your points, however much your score. That's simple. That's literally after one sub, it's like you run another test, you run another test, sub it, run another test, you sub it, and it literally is like maybe 30 seconds to a minute to a sub after you run a bench. It's so fast. It's so fast. Running this again. It should be around 48.5, 48.6. Yeah, but all you have to sub into it, literally all you need to sub is put a picture. Ooh, that's hard to do. Put a picture. It already has a screenshot for you. Everything's valid from it. You just gotta put a picture if you're in top 20. Oof, so hard to do. Yeah, if you want to, just to make sure you have more information on what you've done. You don't have to. It has all the information in the Benchmate. and in the save portion. There you go, 48.5. So have 1.45 gig or 1.464 gigahertz. Yeah, free SSD. Lucky you. How'd you get a free SSD? Yeah, it has all the necessary data as long as when you save the Benchmade, when you click save and you see in the side in the little side over here, in the little right side there, as long as it says that it's valid, and then you gotta watch and also for like competitions, you gotta watch for percentage for valid. To like point 0.03% or 0.1% valid. It's gotta be pretty damn valid, man. My best was 46 at 1.514, which was it gave me some decent points, except for I don't want to just put the voltage to it. And the post GPU stickers. Oh, those are, if you look, those are probably for competitions. Those are probably for competitions. There's a lot of really good overclockers that don't even run every bench. They only run benches when there's competition, really. Or they'll try to go off for some globals. Or stay around with the globals. They already have a lot of hardware, so they just work on the globals. And then you'll see some really odd subs. And it's because, well, it was a competition that was held. There's so many competitions. Like a lot. So that's why you'll see some odd valids. But why is there pictures of this? Why is there pictures of that? Why is it done like this? Why is this a CPU only like this many cores? And yeah. Oh, 100%. Terribly, terribly done too. And you don't want to know how many I can actually report. I've seen over 600 I could have easily reported. No, PhysX 32-bit is what's missing on the 50 series. There's still PhysX 64-bit. You still No, you still have PhysX 64-bit. It's just PhysX 32-bit is for the older games. So you're missing out on that. Yeah, man. It's an insane amount. An insane amount. I guess it really does not matter, though. Kind of figured. For some reason, saying 1.463. There should be... There is PhysX 64-bit. Why is it showing only 1.463? It should have went up to a little bit farther than that. What's going on, you? What's going on, you? Let's put this up a little bit more then. Ooh, not that far. Alright, 1.3 volts-ish. 1.3 volts. 1.476. I don't know if it's gonna pass though. I don't have the cooling that I should have on the actual board. Keep it nice and chilly. Kind of want to put the card together though and run it on air and see how well it performs. It's not going to perform well. Not at ambient temp. Maybe chilling it down a bit, yeah. 48.101. No, just a server fan. Just a 6,000 RPM 80 millimeter fan. No, I have to make a custom heatsink of some sort to actually do it on water better. They're cool to the touch, technically. They're cool to the touch. When it's running, not so much. When I had no VRM on it, that's why why it wasn't passing at 1.5 gigahertz there, at 1.45 volts roughly, wasn't passing. It's just due to the fact I didn't have a fan on it. So wondering why it wasn't passing. Yeah, the VRM's got a little warm. No, it seems like with the high airflow server fan I have on it, it seems to work. Generally, I have two of them on it with the Noctua fan on the memory chips, though. That keeps the board pretty dang chilly. And it's about 20... Wow, that's a little off. So about 23 degrees. 23 in here. How warm is warm? Warm. Like, it's not like it's burning you. It's not like they're burning you. The chokes, they get a little toasty. But not burning you still. Without the fans, though, yeah, she was... toasty. The VRMs were toasty. I mean, I could set up a yeah, give me 1 second. I'll check the temperature with a thermo probe. Alright, so we got the old school thermal probe. I've checked it with new open bench anyways. Does it actually work good? Oh, I gotta download it. Fucking download it. Fucking hell. Fucking hell, man. Does it actually work on these older cards? I didn't realize it would work that good. I got a thermal probe. I'll just put a thermal probe on it. Actually, I got two of them. Actually, I got three of them. I could put three of them on it. One on the choke, one on the VRM, one somewhere else. Where's the download? There it is. Let's go. We got her done. Yep. I'm out. Yep. There we go. Yes. Let's go. I don't know if you could trust it, to be honest. I was like, where is it actually getting the sensors from? Where is it actually reading? Isn't it crazy how much power we draw? We draw so much power. Like, uh, not really. Uh, well, I mean, is there somewhere else I should be looking for the actual temp? I don't see no temp. Nah, it's fucking useless in my opinion. What we're gonna see the power that's gonna go up to maybe 50 watts when it's actually pulling like 400. Yeah, don't think that's very helpful. No, that's yeah, no, the PCB is fine. Except for I do have, like I said, I have some pretty accurate. I mean, some pretty accurate thermal probes I could technically put onto it, and I could just throw it onto it. It would no problem. So I just don't see that being useful in my case because I literally hard modded the crap out of it. So there's literally no, you can't tell the wattage. You can't tell the wattage. Temperature is the only thing you'll actually be able to see. Voltage you cannot see unless you're looking at the multimeter that I'm looking at, which I wish I could show, but I can't. Yeah, no, they're not bad. Lick it. Look at he says. Look at he says. My God, we got the screen that's so hard to. I mean, if I make it so it's in 2K or 4K, it's unreadable for everybody. Let's do 303. 303. Go. Still at 1.33 volts. Yeah. I'm very solder about that. 1.35. I gave it a little extra, so it should pass. Seems like the core is staying a bit cooler too now that I have a fan on the VRMs and that, which is good. 1.489, almost 1.5. Almost. Oh my god. It's not even like it's my best. Like my best is 46 seconds, so brutal. Oh, I can't wait to do this on chill to be better than yeah, perf cap. Oh yeah. Oh yeah. Kind of figured. I mean, kind of figured. So I mean, oh, we've hit a max. Wow, board draw of 80. It's actually reading 82. Oh, what? How much wattage am I at? What? I don't want to know these numbers. 80. So pin 8 is saying 80. 80. 84 at the high. 84 at the high. Huh. I wonder. I should redo the resistor on that one. Actually, I should just redo all the resistors. Should redo all the resistors and maybe not do the PCIe slot. Although it's PCIe slot's only gonna do so much anyways. So actually, yeah, it probably won't be an issue for PCIe slot. Cause yeah, it's only reading 0.6 the whole time, so it's not an issue. Yeah, of course, perf cap though. Yeah, of course, it's only gonna show 1.2. Point 0.00. Chip power draw max. It's saying a max at 84. We gotta be around 300 plus watts right now. The BIOS has a 219 watt max. So we're probably around 300 right now, if not more. Needs more voltage. Let's try to do. Ooh, that's probably a little much. That should be. Yeah, should be. It's not. was at 1.515. Best I did was 46. And I've tried different batch size, reduction size. Some people were doing 10M, 128, and what's 5M, 128. Oh, I guess I haven't tried CUDA. I haven't tried CUDA. Generally, when I'm doing my testing, OpenCL GPU seems to be the best. I did not want to do that. Yeah, that's the thing. I tried, and my scores are absolute ass when I did it. Why? Don't know. Probably because they're on LN2 and their efficiency is just way better. That's the only thing I can come up with on how theirs is so much more efficient. This is like a brand new OS. 42? Okay, so CUDA does matter. CUDA does matter. Oh, this is a streaming SSD. I don't have a benching SSD made up right now. For GPU Pi, does Windows 7 or XP matter, or is it fine with a Windows 10 21H2 driver? So yeah, CUDA does matter. 5M 128, probably not the greatest though. I could probably do better at 5M or 20M 512. Yeah, that cool down though. Just get a little toasty. Pretty far, but if you check out some of the enthusiasts, I've checked out a bunch of enthusiasts. They're out in the shed in wintertime running. They're definitely doing cold. They just haven't been caught yet. Yeah, way faster already for 20M 512. It's already faster. Just on the first two runs. Cold side, so going below zero. Ambient temp. Yeah. That was me last year in the shed. I had my electric coat on, benching almost every single night. -10, -15. It didn't get that cold last year, unfortunately. Okay, maybe was a bit better. Although there was a hiccup, maybe it could have been better. Although I saw 10M 128 also very good. I'll try that too. CUDA is really good though for the 770. Man, it's odd. I guess yeah, maybe the older GPU, a bit older is better. 1080, 1080 Ti, OpenCL is better. Way better. I was wondering why my scores weren't adding up to my old scores, and then I was like, oh, I'm using a CUDA instead of OpenCL. Switched it over and instantly started beating my old scores, so. So that's pretty good though. So I'll try the 10M 128 as well. Yeah. I wasn't even thinking when I was doing the benching. I'm like, man, why is my score so crap compared to my old scores? I looked I even asked in the Discord for Team Wag Discord. I'm like, has anyone? Oh, have you tried this? That's for CPU. Oh, yeah. No, I figured it out. I was in CUDA instead of OpenCL for this graphics card, and OpenCL for 1080 and 1080 Ti is better from my testing at least. Yeah, keeping the VRM's cooler is nicer. Room temp has gone up like 0.1 degrees, and we've actually gone down in temp on the core just due to the fact that I was able to keep server fan on the VRMs. That's how much heat transfer goes over to the core. Ooh, 10M 128 seems to be pretty good. Around 43. Maybe 5M 128 could be best. Thank you, Bench, because, yeah. Thank you, Mark. I didn't realize CUDA would be that much better. And I'll get a new operating system set up too to do more benching. I have okay, if anyone was here in the beginning of the stream, all my benches that actually that was pretty good. 5M 128 though is gonna be the best. All my benches that I've done with the GTX 770 was just to see how far I could push the graphics card. The actual CPU and RAM was stock. 4,000 megatrans per second RAM at JEDEC timings, JEDEC speed, JEDEC timings. The actual CPU was stock, 100% stock CPU as well. And yeah, once I do some tuned CPU and RAM on these as well, it's gonna be way better. And my graphics score actually crushes people's graphics scores, crushes them. Like I'll be getting a lot of either second and first on some benches, or a minimum on all the benches around top 20, top 10. Crushing, I mean, absolutely crushing GPU scores. 5.5. In benches, it only does 5.5, right? Yours overclocked. Your 14600K, you should be overclocked to like 5.6, 5.7 easily on P cores. I'm talking easy, easy, easy. Yeah, easy. You should be easy there. Never use a cheat sheet too and actually do that to show the actual what each bench needs for all core. Yeah, 5.5 all core. Yeah, yeah. So 42886, we'll do 5M 128 again. I'm pretty sure it was like 42.5-ish. Try to let it cool down a bit. Seems to be better at certain port. Oh, we hit a limit. Just random. I should have let it cool a bit more. And that's when, again, like I was talking about before, that's probably like a delay in that transient spike with the way the vid works. Vid was still on a low when the transient spike hit a high, and then that counterbalances and does that. It's very, very rare on GPU Pi though. It's very, very rare. On Legacy, it's so easy to do. So easy to do. Gotta be very specific on the voltages. That's why I did a lot of testing on voltages with clock frequencies for certain benches. And then, oh yeah, it's also on normal. We can do real time. Yeah, we are. All right, and let's do this. Optional tweaks. Ooh, didn't want it there. Over here. We'll do optional tweaks. Math optimate. Unsafe. We'll just see how fast we can really go. Five nine. As long as you can keep it cool. As long as you can keep it cool, right? It's all that matters. Also, try to keep your voltage low. Very. It's And there's that because I stopped it because we were only at 1.439. I should have left it because it was eventually going to go to the 1.528 there. And because when I stopped it there, the load voltage went up as it was switching over from. Oh, it's so annoying. Maybe. Yeah, enough of those clips, man. Yep, and then generally with the 13 to 14 gen, there's it depends on the CPU too, right? It really depends on the CPU for the P cores. What the actual voltage is needed to get past a certain limit. To get past a certain limit on the actual CPU frequency, it could be 5.6, could be 5.7, 5.8, but you might need a lot more voltage to pass that threshold. Once you pass that threshold of whatever frequency for voltage, and it also requires with temperature too. Temperature can actually help as well. But once you pass that, and as long as you can keep the temperature good, you only need to increase the voltage a little bit too to increase the frequency after that. But generally, I've noticed on so many different CPUs that there's a hard point. There's a hard point. We don't need to increase the power limit. 1.528 takes 1.38 volts. That's crazy. I'm hoping when I do chill, I don't need this much voltage, so I can go give it a little bit more. So 1.3 volts is a little much in my opinion for around 40 degrees Celsius. 42,839. It's not bad. Yeah, wait. The voltage from 1.38 up to 1.4 volts without load. So I'm just gonna wait. Make sure we don't trip anything here. Oh, you're on a low end 14th gen. There's no issues. It only mattered on the CPUs that would pass or can utilize the 512 amp perimeter. Oh yeah, people are getting good scores 265K. Yep, yeah. Yep. And it's good to have nice stable settings there. It'll be decent temperatures and I still need to figure out how to get. Ooh. Oh, this looks terrible. I want to move this. Yeah, let's move that one. And this is the longest part of me submitting. Setting it all up. Boom. Depends on what you're benching. I'm not sure what you're benching. Save. Yeah, I'll do that later. 42,839. That's not bad. Now, this probably won't pass on. Oh, I didn't mean to. Whoops. Close all that. What? There's no X. I don't have XMP. I have bare crappy sticks that I overclock. I don't have any XMP'd sticks of DDR3. They're all just JDEC. 3770K is stock right now, though, with 16 gigs of RAM. Don't think it's gonna pass. We'll find out, though. We'll find out. Yeah. 11, 11, 11. Yeah. Yep. 12 600s. Jada? 12 800 Jada. Yeah. What you saw is correct. JDEC. 1,200 bucks is nothing for decent suspension. Just bite the bullet for the 2K front and rear. That's, yeah, that's a good price. Yeah, that's pretty good. I mean, either or is a good price, to be honest. For decent suspension. Good price. Yeah, what you saw there, Persona, yeah. That's correct. It's nothing crazy. Just JDEX. Believe they got JDOC all the way up to 1866, to be honest. Maybe 1600 is the max for JDEC, and then after that is XMP'd. But I'm pretty sure they have JDEC for 1866 too. I could be wrong. S 240 SX, yeah, definitely 240 SX. Here. 1.09 puts me up to 1.2 or 120 millivolts extra. Memory down, core up. Let's do 326, I think that is. That's 226. That's 226. That's not right. Well, I'll let it run. Let's see what we're looking at 1.4 gigahertz. Yeah, but aren't you popping like a 2JZ or something in for the drag, or not the drag race, the drifters though? 40.2. $303 now. Let's see. Should be a pretty good run. It's only at one. Shit, yeah, it's only at 1.33. Shit, I don't know if it's gonna pass. Oh, gotcha. What's plenty for drift as long as you can get it to two-step basically 100% of the time. That's what makes it good. Let's do 1.5 gigahertz here. You know that cool off. That was the craziest thunder. We got thunder. We got lightning. Buzzing in the sound? I don't know what buzzing you heard, but holy. I literally like felt the shock from not the shock wave from the thunder. Like it was like right there. Oh, look at talk my chair. Sure that's not you? Are you sure that's not you? Because there's like no sound. There's zero sound coming out of my mic. You can't hear the fan or anything. It's you. It's you. It's 100% you. Now unless it's only when I'm talking, because my mic is off when I stop talking. Oh, no, no, wait, maybe, yeah. Maybe the EVJ capture card, but I'm pretty sure I have it turned off. One sec. Oh, no, I don't have it turned off. One sec. Yeah, I did. Yeah, my bad. Is that better? There is a buzz. Is that better? Yeah, because I just got the EVJ capture card set up on this setup. So you're hearing a buzzing. Together I can beat schizophrenia. We are one. 1.5. 1.5. 1.489. Okay, whatever. 38.1. I can do better. I can do 1.5. 1.5. That should be 1.5. We'll let her cool down again. Sound is perfect now. Oh, I'm glad. I'm glad it's good. My bad. I didn't realize the EVGA capture card. I forgot to disable the sound because yeah, you'll get that if I don't set. I could set it so that way you can hear the sound through EVGA as well, but I'd have to set it so that way it does a filter to make sure you don't get that buzzing. Because it's the way the audio gets done through it, through the HDMI, because it's the HDMI cord technically that I have for it isn't the appropriate HDMI for it for this graphics card to the EVGA graphics card. Sorry, the graphics card to the EVGA capture card. See if we can do 1.5 at 1.34 volts. Might be able to. 1.515 at 1.34 volts. I had hope, okay? I had hope. There was hope. One 1.35 volts. Yeah, basically. I mean, I could set it up so that way I can put the audio through the motherboard to the EVGA graphics card so that way I can bypass that, but it's through the audio and so through the HDMI, unfortunately. I don't have a was it 3.5 millimeter jack to another 3.5 millimeter jack to do that. $1.35. Oh, I gotta rerun that because maybe it just had a little hiccup. Maybe. Gabby, you want over here? No? Fine, be that way. Why is it still holding that 1.5? Yes, she is. Yes, she is. Hi. What you doing? Did that thunder scare you? I was like right there. You felt it too, didn't you? I mean, holy the thunder. I mean, when I say I could literally like felt the shock wave, I literally felt it. It was like right there. Maybe we'll put the voltage. We're like we're like at the lowest end of the pot, the potentiometer. So I mean, just a little bit of a twist goes voltage. Oh, you want 5 millivolts? No, you can have 30. Yeah, I'm on surge. I have surge plugs. Yeah, buddy. Yeah, buddy. Yeah, buddy. Yeah. None of my electronics get plugged. Well, I guess some electronics get plugged into not surge, but any of my PC hardware get into surge, and they're construction grade. They're made for it. And technically, a lower amperage. There's like a slight lower amperage than the actual wall plug itself. So like it's way better than normal. Like swatting flies. I don't know. I don't know. We're at almost 1.36 now. No help from you. 1.37 volts. 1.37. Oh my god, it was worse. It was worse. No load, 1.392. 22 millivolt difference between load and no load. Maybe I'll give it a minute to let things chill. Oh yeah, I recommend surge protectors. Yeah, man. 100%. Get you some decent quality ones too. It's always recommended for your PC hardware. Yeah, we have all rain this week. All rain. It's not gonna get cool, it's just gonna rain. Rain, rain, rain. Just gonna run it anyways, because it's not lowering. 1.179. And yeah, I didn't think so. There we go. Now it lowered. Oh man, we're up there. Yeah, we got nothing but rain. Rain, rain, rain. Nothing but rain. Rain, rain, rain. I wish I could actually monitor the actual VRM temps when I'm at this kind of voltage. As yeah, the limit we're pushing the limits of the VRMs amperage. Like we are really pushing it. No load 1.41 1.4 over 1.4 volts with no load. Yep, and then should have left it, would have been fine there without doing anything, but then it's hitting a certain thing and it's so annoying. I use Belkin. I guess those work. I use a Mastercraft construction grade surge protector. Oh man, I'm not even sure how much. Yep. Yeah. Yeah. So when I have, well, I I need to get a new UPS. I have a UPS that has pretty good built-in surge protector too. Does everything for Ethernet and that as well, but I just don't have. I mean, I could technically just use it as a surge protector, not as a UPS though. But I'd rather have it as a UPS as well. They are, especially for one's size that I would technically need. Oh, this is a lot of volts. A lot of volts. 1.415. Nope. We'll just run it at the 1.489 for now. It's just tricking the controller into thinking it's not putting the voltage that has been requested in. 1.415. And I lowered the voltage now. The voltage is lower now, and we'll just run it at 1.489 until I do chilled, and then I'll try to do up to 1.6 gigahertz. Should be able to do it. Yeah, a lot of people like those ones with the USB as well. No, not similar to a shunt mod. So give me one sec here, and I'll show you what a shunt mod versus a feedback mod is. Do this. Open up GPU Z here. Feedback shunt mod is not tricking power delivery. So shunt mod makes it so that way what is being read by the controller for showing how much power is actually going into the board or being utilized by the board, the controller for that, and then the actual voltage, even though you can do, where's the actual voltage? Where's my voltage? Right here, VDDC max 1.125. So this right here will show. I guess MSI Afterburner shows it too. 311 here. $311. You're consuming 100 watts when it's actually. Yep, but that's a different controller that you're. That's a different controller that you are tricking. Yeah, so the feedback mod is basically you're putting resistor in front of the feedback mod. So the feedback line. So the feedback line is actually for the for the NCP 4206 controller. The feedback has, let's say it's it's using, it depends on whether or not it's what boost it's on, but for the actual voltage, you're basically just putting a resistor or potentiometers, which is built-in resistors, is potentiometer, right? And you're tricking it as in with the resistance going to it, it's acting like it's, and that's just one portion of the controller. So there's many fallbacks into just doing a feedback mod. Lots of issues with feedback mods, depending on the real controller, but NCP 4206 is not the greatest. I mean, does it give you way more performance? Hell yeah, but not as much as other portions. But yeah, you're tricking it. You're tricking it. But it's adjustable, whereas the shunt mod is not adjustable. Yeah, it's not adjustable for the actual shunt mod. The shunt mod is, well, you put in what I like to use is 2R2s or 2.2 ohms on top of the actual shunts that are already there. Shunt mod, piggyback shunt mod, add on to it, and that will guarantee that it's not going to put the card into a limp mode. For one, for all the cards I've tested from 700 series and up, 2R2s work great. Now, for the feedback mod, it's different, as in you're tricking the actual, what the controller is seeing for the actual voltage being read. But then there's a lot of issues with it. A lot of issues. Now, it's not just a feedback mod that I did on this card either. I had it on like 100 capacitors, ceramic capacitors, and big aluminum caps. Yeah, correct. Yeah, you just have to read what controller the graphics card has. Older graphics cards, kind of the same thing basically as well. Just got to read what controller it is. You got to find what pin that resistor, it's going to be a resistor to begin with, that goes in front of the pin to the actual controller, that goes to wherever to get the reading from, right? Like you have to do trace back, and then you just basically solder a wire to that actual resistor, to the back end, not the front end of the resistor, to the back end of the resistor. So that way, when you're using a potentiometer or putting a resistance in front of that resistor, you're increasing the resistance and therefore lowering the voltage that the actual card is, the controller is reading. Does that make sense? The higher resistance value, the lower the controller reads, the higher the actual voltage to the core will be. Well, it goes through VRMs too, but yeah, voltage regulation, and also helps with transient spikes. Actually, it helped a lot. I'm gonna be adding more. Sounds like it. It's good. But yeah. Now what I also did with the ILIMFS pin. It's a pin for overcurrent protection. I did replace that with a different resistor itself. It's I can't even show on such a small screen now. You won't even be able to see it. Literally, if I even held it right in front of the camera, you still wouldn't be able to see it. I completely changed that value from a 7.2 kilo ohm to a 9.3. It's around 9.35, 9.38, probably a 9.4 kilo ohm resistor. So that increases my overcurrent protection from 150 amps that this card has to roughly 185 plus amps, which is still roughly in a safe location for this VRM. It's actually fairly safe still, as in it shouldn't blow it up going to 185 amps. Should. But I added capacitors from the power source in, the 12-volt power source in, and then from there I added more capacitors to the VRMs, and then after that I added capacitors, so not just ceramic capacitors, but also aluminum 16 volt 270 microfarad capacitors to the actual core. So what I had was a bunch of 22 microfarad ceramic SMD capacitors, and I actually soldered those to the back of the core. I wish I had a bit higher, like some 47 microfarad, but I don't have any of them. I desoldered them out of other boards, other donor boards, and this mod cost me nothing. And then I got a bunch of caps as well that I desoldered. Yeah. Yeah, if you're strictly just gonna do a feedback mod, it's worthless. It's worthless just to do a feedback mod almost. Like in some legacy benchmarks, there's no gains. Zero gains whatsoever. You might be able to get 1 millivolt, maybe 2 volt more on newer benchmarks and GPU Pi. You might get away with increasing the actual voltage a lot more than just 1 or 2 millivolts, but it's terrible without extra caps. It was absolutely horrible. Horrible. And now with the overcurrent protection, I'm not sure if you really needed it. I did that for just making sure that I was not hitting an overcurrent protection and that I was guaranteeing I was hitting a OVP or over voltage protection. Ah, Gabby, you almost got sat on. Yeah, yeah, I guess that makes sense too, right? It would also be on GP. It would also be on GPU. The drivers can play a part on these older ones too. Drivers can play a part, and then again, also the controller itself, right? Apparently, from my some more research that I did too, VREF and SenseMod does not do anything for this graphics card. I was gonna try to do something, but then I was also thinking, what if I mean, what's the point of doing it though? What if I cut the traces to the actual vid, right? Cut the traces to the vid, and then add in a resistor, right? Just add in a resistor to the vid. Would I therefore automatically increase the voltage, and or would I be able to actually do a better? I know. But I'm not saying that's somewhat what a vid mod is. It's somewhat. What you're doing with a vid mod is using a switch. I wouldn't need a switch. No switch. No switch whatsoever. And then would I have to take out GPU I/O? And it's just some theoretical, some theories I was thinking of. Yeah, other protection will kick on, or is it like? Oh yeah. Oh yeah. It's not even like a for what I find is it just screen goes black. That's it. The screen just goes black at 220 millivolts is what's read onto that. The card is, I mean, I'm still in Windows. Everything's still in Windows. It's just no more graphics card. It's 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 protection. It's some sort of protection. With the vid mod, though, you need a switch, and then you need to switch it in a certain sequence to get the actual voltage. If I, let's say, cut, I know I'm not even going to do this. It's just theoretical stuff that I was coming up with. Again, it's because I'm going to be making a video on why this vid mod is good, but also sucks to begin with, and why you should just do the vid, and then point it to Eckaberries and whoever else's videos on the vid mods, because they explain it very well. But I know you're cutting the trace. You're cutting the trace, putting the actual whatever source, generally a 3.3. Oh, off. Oh, I'm way less voltage than I need. So if I had an SM bus to actually hook up to the card, like an actual a recoder basically for it that you just plug into a pin into the card. If I can just do that, I can literally redo the way the card actually does that, and I would technically have no limits with an FB mod. I don't have one of them. I don't have one, and I don't want to do that. I want to do strictly hard mods. Just hard mods. Screw software, man. Screw software. Yeah, exactly. Far easier. Far easier. I don't want to do easy. What do you think I did all these tests? I did all these tests from beginning to end to see how things actually can progress and or worsen. Guess what? Removing the actual over current protection resistor, removing it does nothing. I thought for sure maybe, it'd be like, no, no, something's wrong, something's wrong. No, it works just like as it should. I added it back. I still added it back. Well, actually, I added a higher resistance, technically, but I still added it back just because. But it did nothing. I literally took it right off. And that goes to CS Comp. How does that make sense? Which means if CS Comp and the actual ILIMMFS actually is not corresponding with each other properly, there should be issues, but there isn't. No, I don't think you can. You can try. You can try. I've never tried it, to be honest. I mean, you can always try, right? You can always try. Oh, see, I didn't realize you could do that. I guess it makes sense that it's not, since it's not an actual graphical output. Kind of makes sense. I mean, you're only gonna gain maybe, what, 20 nanoseconds? Milliseconds? Not even, sorry, nanoseconds. Milliseconds by doing that? Or is the efficiency that much greater? I wouldn't assume it's much greater, though. Yeah, yo, yeah, oh yeah. That's why I tell people only be benching on one monitor. Or gaming on one monitor. 1.320? 1.32? Is it actually going to pass? Is it, if it is passing, 1.32 volts? Oh my god! We almost passed at 1.32 volts. It's always the last run, though. I didn't think we were going to pass. It's 1.33 to 1.34. But yeah, the feedback mod's not the greatest. Feedback mod with a vid mod probably be pretty good. Now, Bench, Mark, what I'm probably gonna do is do a vid mod. I'm probably just gonna do a single vid mod that's just a single one at 1.6 volts, and then just do a reverse feedback mod. On air? No, this is on water right now. Just the core's on water. There's no cooling on the VRMs and that and memory with besides a fan. I was gonna put it back together. So if you did do a switched, like if you do a switch, and depending on like if you do a switch, a vid mod, you probably won't be able to put back on the original cooler, air cooler. You might depending on card, but you probably won't be able to. And you'd have to be careful with what you're switching the actual voltage out to. You have to have something to monitor it, right? I'm using a multimeter. And that length of the run does not matter. So the length of the run does not matter. I shorten my run, and I noticed shortening my runs for the pots doesn't do anything either. Again, I was doing testing of my own to figure stuff out. So the wrapping it all the way to the other side does not matter. I mean, it depends on. For 0.7, 5 volt. Well, for yours, for the one you did, yeah. You don't have to do a 5 volt. You could do 3.3. But I mean, even if you did a 3.3, I guess it still doesn't fucking matter. Yeah, but I mean, a zombie board is way more. It's not exactly more complicated in a sense. It's prep work for a zombie board way more. 3.7 should do. You mean 3.3? I know. Put the logic to high, so that way you can put to the code that it's on. But then you have to switch it in a series to make sure you're actually making the actual voltage. Because you gotta send the proper code for it to do the proper voltage. Can't just be switching stuff all willy-nilly. You might end up with 1.6 volts for no reason. And is 1.6 volts with no load on it terrible? Not really, but I mean, is it great? No, it's not great. Yeah, rerun it at 1.32 volts again. Well, you gotta think about weight, right? I haven't done a zombie board, but you gotta think about weight. Yeah, I didn't think it was gonna pass 1.32 again. It's all about weight, and then how how are you gonna position it? How are you gonna set it up into your system and that? Having a smaller board hooking up to your actual board that you're zombie boarding was more beneficial, right? That's why e-powered boards are really good. That's why Excavator should hurry up with his damn board. But prep work is the main problem with power boards, to be honest. And then also, do you have a power board, or do you have the actual whatever board you're using to make a power board? Do you have it so that way you can do the a memory mod too, or is it just going to be strictly for VCore mod? Then, in my opinion, if you're doing it that way, just do a vid mod. A vid mod's way less work for getting the exact same performance. As long as your VRMs on your board can technically handle it, and if you can keep them cool, technically they can handle it. Not as you have a really shitty board. Most people use a zombie board. Really? Most people use a zombie board for using a better VRM, better VRMs to power their lower end boards that they just bought very, very cheap. because I can just reuse this, the zombie board. Man, do everyone reuse it? No, but you can. Eventually I'll do a zombie board. Show how I will want to do it. There's only one way I would like to do it. A lot of people have their own ways, but there's one way that I like, and it'll be stronger in terms of yeah, and good luck trying to do a voltage mod on new cards. Nvidia's got shit locked down. You can trick it into giving you like we're talking like 15 millivolts more. That's it. Really, 1.3 volts? So close. So close. 1.3 or 1.33 volts. That would have been great. I just want to be able to save this one. 38 seconds, not bad. On the newer boards, LN2. Where do you think LN2 comes in handy? You don't need as much voltage and you can crank up the actual frequency. And or hopefully you can get yourself a binned card. You can only go up 30 series and up. Good luck. Good luck modifying them. Good luck. Why do you think I hold a lot of records on the 3070 Ti? Because I have a binned graphics card. There's a ton of people that run 3070 Ti. Ones that run it on water, guess what? Oh, actually, chilled water, I can do that on air. No one's found a way. The only way you can actually get a better, not even better voltage, it's better power limit. Better power limit is just BIOS modding. Different BIOS. Again, I've only found one way to give myself an extra 15 millivolts. That's it. You go past trying to do more than 15 millivolts, it will put the card into a limp mode. That's me. I don't know anybody else that's found a way. The only way that you can do it, like let's say like the 3090s, so 3090s, 3090 Ti's, 4090s, and 5090s, you can get the XOC BIOS. Power limit's not a factor though, especially if you just do a V BIOS. Then wow, you don't have to do any soldering whatsoever. You can just do a V BIOS. That's why my 380 watt BIOS that I generally use, plenty. I will never hit 380 watts at 1.1 volts. Not even 1.1 volts. That's all you get. Actually, it's what you get after doing a pencil mod, but yeah. Is it most? Is it most? Oh, I didn't realize that. And I've been looking, like, why don't they have fucking XOC BIOS for other cards than just the top line? How come they're, like, my 2080 Super doesn't have it? My 2080 Super would love an XOC BIOS. That's crazy. And probably performs really good, too. No, there is no XSC BIOS. You can just find what GPU vendor has the best BIOS and just flash it to that one, as long as it has the same power layout. They all use the same controllers though. Is it the same way I normally do it, just shunt mod, or because I normally just do a shunt mod? Oh no, it's not. Oh, similar mod. Okay, yeah, I would need to be shown that one. I don't know that one. Again, I only know how to do hard mods more or less. It's where my knowledge more or less is. I know what a lot do. Just 100? Still just 100? I mean, you're still at a voltage limit, right? I mean, is there any tools that I can increase the voltage on the 20 series? I know there isn't on the 30. Kind of like with the GT. Do you know? Okay, just because you're here, do you know why my Strix model? I use generally 2R2s, 2.2s. Fours limited? Fucking two. Fours limited? I always use 2.2 on everything, every card I've ever done. 2.2 is just fine. I mean, I don't want to just. I could just try it. It's not hard to take them off. So, do you know why this is GTX GTX Asus Strix 1080? Right? This is a 1080. Yes, it's the OC gaming one. The OC gaming. Why 2.2 ohm? 2R2s, not milliohm. 2.2 ohm. They're not milliohms. That's what's on the GTX 770 right now. That's what's on my 1080 Ti. That's what's on my 1080 Ti 770. Think. What's all my graphics cards that I've done? Nearly do nothing? You mean I've been running this and I've hit a maximum. Okay, well, this nothing. I've hit a maximum. This one right here, this shouldn't have to redo. I've hit a maximum of 2.1 watts and PSA 0.5 watts, and it does nothing? I don't think they're milliohms. 2.2 2R2s. I'm pretty sure they're 2.2 ohm. Maybe, yeah, maybe they are milliohm. Maybe I should redo the resistance on them. Maybe they are milliohm. I know the 2R2s, 2.2 ohm. That's what I even read up on them. No, no. Yeah, I've seen no issue. For 770, 1080 Ti. No, Gabby, no. I think what all cards have I done? Oh, my GTX 1070. I've seen zero issues. They don't even get hot. But do you know why the XOC BIOS puts my memory into limp mode? For some reason, it puts my VRAM into limp mode. And I've tried multiple different ways to fix it. It just puts it into limp mode. Well, the XOC BIOS should work on all Strix models, right? Yes, this is a Strix OC gaming, but Yeah, I don't have all that. No, that's fine. That's fine. Yeah, it's literally just the mem. Core works fine. I can even use the tool to adjust the actual voltages, apply more voltages, PL, and also for mem. But I can't seem to get it working. Works good. Mem's in limp mode though. Oh shit, I didn't think of that actually. I didn't think of that. There's nothing I can do to make it go higher, so maybe I'll try that and see. Because they all use GDDR5X Micron memory. It's not like they are different that way. It's not like they've changed the timings and all of a sudden it's timings that's not appropriate for it because it's all GDDR5X Micron. Yeah, try this again. Is it gonna pass? Probably not. Yeah, I'll definitely lock it. See if that helps. Maybe it does, maybe it doesn't. We'll find out. Tune in next time. Like the 1080 Ti, that XOC BIOS works pretty good. I'm sorry, it does not work at all because mine's the EVGA for the Win 3. I mean, it does 1.2 volts. I guess that's good enough. 38.172. That was pretty good, actually. That's the best run I've seen so far. All the runs at same frequency. Sweet. I'll take it. Ooh. Oh god, no. It messed up. That's alright, we still got it. Did I actually close bench? Close benchmate. I fucking closed benchmate. Well, at least I can rerun it now, like this. Make things look a bit nicer. I still gotta run this. I'm only gonna run it at chilled for the 32 billion. Just because it's an hour-long bench. But I did pre-testing. I should be team record. I should get team record. It's just... And if it fails right at the end, man. Oh, that'd be brutal, man. An hour long. So I tested for 20 minutes and then going against team record. I think G was the team records. Like 59 minutes or something like that. 58 or 59 minutes. Just from going off of his. It looks like I can get the team record. Oh, of course. Oh, of course, I should have just let it sit for a second. Should have just let it sit for a second. Oh, there goes my phone. I'll let it chill out. Give me one sec here. Miller? Miller's E-Power? I've never heard of him. Miller's E-Power. Alright. Oh, so that's what you can do. Yeah, okay. So, yeah. For core M memory. But I've heard it was a hard. It's not. I mean, depending on the card, but it's not. It's some cards depending on what board you're using. It's very difficult to do the actual memory mod, uh, voltage for memory from the E power. What? It's all yours. I'll be right back. Yeah, be goods. Be goods. Be goods. All right. Give me 1 minute. Can we share the chair? Can we share? Please? Can I sit? I want to sit. Come on. Why you gotta be like this? Yeah, so apparently MSI had a thing too for these NCP 4206 controllers as well, but does not seem to work anymore. So I think they got rid of it. At least for my test in it, it does not work. $38,109, nice. That is good. I mean, good enough for now, I guess. Don't press exit again. No, thank you. Over here. There we go. I should check to see what those two place me as. I would like to do 1.5 and up, but still want to do those kind of high voltages for it. Seems to want way more voltage. Way more voltage for 1.5. What kind of gains will I get? Not much, to be honest. Not bad, though. I didn't think to do CUDA. All my other testings on my other GPUs, it's OpenCL seems to be the best. All right. What? Yeah, and the ones I had saved the comp were no good because I can only do 5.2. You know, I had 1100 run. I could have put in for comp, which really sucked. Should have had a saved picked for that. But I think it was before a certain time, so it probably wouldn't matter. Ninth place and still only gets 15 points on GPU Pi 3.3. It's at chilled water. Single stage, it's pretty good. 1.9 gigahertz. Some liquid nitrogen run. Damn, son. Going wild with that. 25th. And that puts me where for 25th? Way under a single stage. And we got some water as well, though. And we got, what else? 2 gigahertz? Almost 2.1 gigahertz? Cubies? Two 2.1 gigahertz. That's wild. That's an MSI board, is it not? Ones with the LED in the back? Yeah, I'm pretty sure that's an MSI board. Oh. Yeah. 9th place, 15 points. And I got 25th place for GPU Pi 3.2, and it gave me 33 points. Still pretty good. But the guy did 2.06 gigahertz on GTX 770. Char is still up there, 1.9, 1.9, and then 1.9, 1.8888887. Holy. But 2 gigahertz? Benchmark, where is your scores for this? They'd be pretty good too, I think. They would. They would be pretty good. Pretty wild. Should be 1,230 plus points after this morning and today, so that's good. Should. Not saying it will. I'm saying it should. Should be up around there. Then I gotta work on my globals soon. I almost got where I want to be to start doing globals, because that'll also give me more hardware points too. It's 3070 Ti. Yes. And I still have to work on my 2080 Super, 1080 Ti, and GTX 1080 still. So I still got a few cards to run. Nah, 9th place. 9th they gave me, I think. Or was it 10th? Maybe it was 10th. 9th, yeah, 9th place, yep. 9th place for that 38 seconds for 3.3, and then for GPU Pi 3.21 billion, 25th place at 42.8. It's fine, I'll rerun them anyways. This is how a Legends are played. It's raining. It's gonna be raining all week here, man. So brutal. I mean, temps don't go down at all when it's raining. I mean, all throughout the night, temperatures stay around 20 degrees Celsius. So temps don't go down, so I can't even do like a little bit cooler runs. Temps stay about the same. 3070 Ti performance for 549. No, I'm not. I like to be able to do some test runs for a little bit cooler, and then when I do chilled, that's when stuff really starts working. You literally get better scores at just lower temperatures at the exact same frequencies, just automatically. That's why actually throughout the summer I can't believe like 35 and 40 degrees Celsius room temp. I was actually getting some pretty good scores. Like I was surprised, very surprised, very surprised. I mean, it's good. That's good though. Yeah. I believe Monday next week it's supposed to be cooler at night, which is good. In my opinion, it's good, but is it great? Not really. Throughout the day, it's still hot. Just give me one sec here. Sorry. Come on, you wanna go? Wanna go? Wanna go? Sec. '90s. I don't know what that is. What is that? 20-ish, 23, 23-ish. Oh, I don't have the Discord open. One sec. Don't even have it open. Oh, there we go. Yep, pretty good. What up there, Egyptian? Don't AMD run hotter since they use more watts? Only on idle they use more watts. On idle. Yeah, it's crazy. Yeah. Constant operate at 90 degrees Celsius is not a problem. No problem. It's fine to run that hot. It's designed for it. Why is my CPU dying? Well, because it's designed for it. Oh, you could probably run CS2 still. Definitely. I believe. Man, how freaking fast do you get that running? 2.6 gigahertz on a GTX 1080 Ti. 2.6 gigahertz. Wild. I don't know it. Hey, come here. Hey, come here. Hey, no, don't ignore me. Come on. Come on. Okay. That's not how you get up. You want to say hi? Oh, my God, we got a kitties. We caught a kitties? Yes, we did. We caught the kitties. We caught the kitties. Yeah, I already said that on my last live stream that I got pushed back. Did you get it? Oh, did you get it? Could be me. Hold on, you can't stop. It could be me. Could be me. It could be me. There we go. Should be a bit better now. The mic's a bit farther away right now, so I generally have it closer. I can get real close. I can get real close. Yeah, I know. Generally have the mic a bit closer with a bit higher of a gain, but I should check. That is, there we go. That is well. Probably help a bit. Yes, she does. Hey. Why don't you come up here and lay down? Yeah? That's not how you... I can't even reach you. There you go. Thank you. I should probably do like a video or do a live stream too of how I do the soldering. Show people a little bit of tips in that. I mean, it's not easy exactly to... It's more or less holding the small resistors. It's quite easy to do the soldering. It's not that difficult. And I don't do it with anything but my eyes. My safety squints. How punny. Yeah. All about the soldering tips. Yeah. it does matter on what soldering tips you do use. Solder itself, there are so many different variants of solder. 50/50 is a good one though. 60/40 is a good one. Yeah, I mean, if you can get yourself some tip tinner to keep your tips in good health, that's another good one. But main thing that you want to do with making sure your tips work good. I know these don't look great. They don't look great, but they're covered in solder, and it's just the 50/50 solder I have does that. And this one here, I only use the tip of it. That's why the rest of it looks so good. This here, I'll do the whole tip. Only as a business? Wow. Really? That's wild. I mean, buying it by the half pound and the 1 pounds are the best way to do it too. Just lasts you so much longer. That's wild. Yeah, that's about here too. It's not like your Egyptian. I mean, I'm pretty sure your Egyptian pricing is cheaper than Canadian per dollar, and ours still sell at that price, 50/90s. I mean, crazy. They're still selling here for Canada for $7,500 and up. An average of $7,500 Canadian. Average. Same thing with capacitors. Again, I don't have bought-in capacitors. These are all from donor boards. I gotta do more too. Get more of them. So like the legs are not very long on them. So it makes soldering a little more challenging, or you can just solder legs to them, which it works just fine, to be honest. From testing, could do a little bit worse impedance, but they work good. Basically, they're VIP. What's better on the Matrix besides the 800-watt BIOS? Not sure if the VRMs are actually better or not, to be honest. And I don't think they're bin chips, so I don't think that even matters. Yeah, I did the live stream on that. Pure gold. And we're not talking about the Dahali. The Dahali edition? That's just gold coated. They got a pure gold, was it 12 pound? 12 pound or more GPU of gold? Oh my god. Crazy. $3,500 USD for the ores? Wow. No. Like the 1080 Ti Kingpin, those were bin chips. Those were bin chips. Solid silver. 2,500. Wow. Yeah, still though, gold plated still pretty wild. Yeah, exactly. Is it ever gonna be in stock? Yep, has clock speed written on it. Tested at. 4K for the Astral. Yeah, there's still crazy prices, man. There's still wild pricings. Absolutely wild. And I still need to finish the block eventually. I still need to finish the block, solder on the actual fittings. Finish that up. And then I would love to be able to test it here at some point. Be awesome. See how well it actually does. Yeah, it was a ROG Strix version, I think. I wouldn't presume that it has the Noctua has better cooling. Maybe it does, but I don't think it does. Still over MSRP though. Because even though AMD sold a lot of their 9000 series CPUs and GPUs, they didn't sell that much compared to NVIDIA, unfortunately. I'll have to check out that review. I don't believe it uses a full size. Oh, how's it going, Daniel? How you doing? Oh, not too much, you. 5080, still 1500, can't find less. Wow. Twelve by 25s? I don't think so. That sounds pretty small, to be honest. Well, that's good. It's good, that's good. Oh, it's their A12 by 25. Oh, that's what you're saying. Yeah, exactly. Right there. Yeah. Yeah, yeah. I was like, man, like that doesn't make sense what you're saying there, but yeah, that's the model. Yeah, that makes sense. Well, they're not the standard model. They're cut off version. Like they're not full squared. Yeah, yeah, yeah. It's because you need static pressure, right? Airflow does not matter. Static pressure matters for fin density, right? That's the only way you're gonna get decent cooling. That's why like the fans with a ton of blades that have a slight curve to them are more efficient for pushing the air through the fins. So you can push more air through the fins at a lower speed, and then Noct was good with their design, so yeah, they'd probably be pretty quiet. And again, the sharper the blade, the louder they are because they chop the air too much. So again, Noctua is designed there so they have a more of a rounded front. Yep. perfect, right? Perfect back. You would assume perfect back in 2001, but it's not. It wasn't perfect. There's so many designs that can be done, and they might have had a perfect design, but they're loud. They had sharp fronts, sharp front blades, and having a sharp front blade is just loud. They're just really loud. It's like my thermal right fans I have that came with the Peerless Assassin 120 SE and Peerless Assassin. They're great for moving air. They really are great for moving air, but they're loud. They have such a sharp front. Why do you gotta keep asking how old he is? There's a very fine file on my thermal right fans. Yep. Yeah, it sounds way better just doing that. I use sandpaper generally to sand down the front ends. Doesn't take away the airflow, and it makes them a lot quieter. Yep. And you can't even hear it. I got a 6,000 RPM fan beside me, server fan. One that chewed my finger up pretty bad. It was moving. I went to grab it and grabbed the fan blade. It didn't care my finger was there. It kept moving. I should make a vid on modding fans for noise. It's just a lot of people might not realize you don't have to go nuts with it. It's just grab a nice high grit sandpaper and then do it a certain way. There's like you can make it into like a nice little tool. I mean, I have a bunch of fans I could show how to do it because they need to be done. Yeah. Uh, Now, you tell me, would that suck putting your finger in? Because when I said it did not care, I mean, look at the torque on these bad boys. It did not care my finger was in it. No, it's just an 80 mil. Just an 80 mil. 0.37 amp. They're just a high torqued motor. Yeah. They're 6,000 RPM though. Just they're high torqued. They got huge motor in them. They're just all static. And yeah, when these blades are this small and your finger just gets in there, they don't care. They don't care. Yeah, I have some threes. Oh, okay. 2.5s. 2.5s. But these are nasty. Nasty. You can't make these quiet. They're just you can't make them quiet. But they're not the high torque. They're not like these. These high torque, even though they're only 0.37 amps, they don't slow down. Yeah, this is a 2.5 amp. They can go a lot more than 2.5 though. A lot more than 2.5. But yeah, pretty brutal. These are just really loud. Like you can slow these ones down, even though they're high ampered. You can slow these down quite easily. These little, even though they're only 0.37 amps, these, oh my god, you can't. You put your finger in there and you just keep pushing down on it, it will just continue to chew on it. Yeah, finger choppers for sure. Oh my god, brutal. Those little ones. And then my server fans, they're also loud, but like yeah, I mean, they're not crazy amp either, but they're not like those little ones I have. Those little server fans that I have, oh my god, they're the worst. They do not slow down. Yeah, you can literally shred a pencil with those ones too. They're not high amp, they're just high torqued. The motors on them are massive. When you got the same size, in a little fan like this, yeah. Actually, I should take them apart and actually show people like what makes the fans actually have the static pressure, as in you can put lots in front of it and the fan's not going to slow down, and also the blades as well, because this one right here, even though it's 2.5 amp, you put something in front of it, it will slow this fan down. This one, nah. Like I said, you go put your fingers in it, it doesn't slow down. Yeah, they're brutal, man. Just wild. And what's cool in the PC that the GTX 770 is in right now, I have a Noctua fan on that. I like my Corsair magnetic levitating fans. They're really nice. I do like them. Yep, big motors is what you want. High torqued big motors though. So it'll be the coil dense, the thickness of the copper per coil per chunk basically. So you call it per phase, but it's not really per phase. No, you can't put links in YouTube. Discord channel. Discord channel in the link description below. That's where you'll have to go. That's a chunky motor. Ball bearing style shaft. That's great too. Yeah, that's a chunky boy. That's a chunky boy. Yep. Dual ball bearings, perfect. It's 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 not like it's gonna last. Dual ball bearings exactly last that like they're gonna last longer. It's, let's say you start putting a lot of pressure and or it can be shifted around, vibrations and all that. That's when it can come into play for actually handling that, and they're always gonna stay more centered. Oh yeah, to cool X299, no doubt. No doubt. Yeah. That's why I would love to get some X299 and play around with them. Socket killers. Yep. Have their persona. Yeah, I know it's a very fun platform. That's why I would love to get into it. One day. One day when I start making money. Till then, I'll do what I can do with what I got. Put that over there for now. I need to invest in more soldering tips too. Some bigger soldering tips. So I can do better soldering on. Well, I can still do some decent soldering, but for thicker wires and that. Oh, really? Yeah, he does a lot. Yeah, right. Yeah, I wish. I wish there, Daniel. I wish. But not really. Too much work. Yep. Depends on what you want to do for what fan you want to do. Like, for what fan you want, right? Depends on what you're actually going to be implementing the fan on. What you doing, Gabagoo? What you doing, Gabagoo? I mean, yeah, you can always invest in fans later on, too. I invested quite a bit of money early on in fans. And then the fans that I like the most are definitely the Corsair magnetic levitating fans. They're quiet, tons of RPM, got some static pressure into them, so it works good. And then magnetic levitating, they last forever. Basically last forever. Yeah, the RGB adds horsepower. And the Corsair magnetic levitating fans, no RGB. Perfect. I should probably get some sleep here soon, though. I've been up for a long time now. Not sleep was for cowards, but say sleep was for the weak. It's only like 1600 and 2000 RPM. More or less because a lot of people complain about noise. And then most people don't set their own fan curves in the BIOS. So if the CPU ramps up the fans, it's automatically gonna put the fans RPMs a lot higher, right? And you can't change the RPMs. It's just gonna set on percentage, not on RPMs. That's generally why. Everyone complains about noise nowadays. It's so loud. It's so loud. Well, if your CPU wasn't at 90 degrees or 95 degrees Celsius all the time, it wouldn't be so loud. Whoa, hello, yes? What you want? Well, come here. Oh, wow. What's your problem? Yes, I should get some sleep. Why don't you give me that? I don't want to hear it. You gotta wait like 4 hours. So I'm not even gonna get much sleep because of you. No, I'm not. What do you want? Hi. You get comfy? Of course you are. Yep. Yeah, it's probably not even your thermal paste that is the issue. It's mounting pressures proper. Because it depended on the cooler and how the CPU is domed up can determine on your. Just want to make sure it's an even pressure to make sure it's right at the center of pressure, because that's generally how those CPUs are with coolers. And it doesn't have to be super tight, just gotta be nice and even mounting pressure. Nice and even. Oh. Alright, should be ending the stream now. So I need to wake up at a decent time because I gotta go get some coffee for tomorrow. Yep, that's one thing good to do. Do you just do finger tight, or do you use like a screwdriver or anything like that? Because what you can do is try to do like same kind of pressure from corner to corner, and then corner to corner, corner to corner type deal, and tighten it up. Just like a corner turn each single time, or half a turn each time until it's tight. Oh, it has two screws. Oh, it's one of those ones. Yeah. So it's four screws down onto it, and then it has the two screws on the top part with on metal brackets. My best opinion. Yeah, well, it's somewhat like AMD. For my best opinion on those ones is put the first one down onto at least two or three threads, push with your hand on the AIO down, and then tighten two or three threads. But then you also have to make sure. Just leave the spacers as they are for now. They're generally good for what they are for that. You don't want to put too much mounting pressure because if you don't have a do you have a contact plate? So if you don't have a contact plate, you put too much pressure, you can bend the actual CPU, and it could actually break it. Well, 50 spacers are thicker, are they not? Put the 1700 spacers in it. You got the plate, yeah. Put the 1700 spacers in it. Your pressure might not be appropriate then, because I'm pretty sure the 1100 the 115X spacers are thicker. Yeah, yeah. So I'm pretty sure. Give me one sec. This is 1700. Just doing comparisons. Why not? Shit. I get some full one. No, those are for the other one. Okay, well, yeah, the 1700 is thinner than the 1700, so the 1700 will be better tight mounting pressure for sure. Yeah, correct. Thank you. I'm just trying to figure where I put all mine. They're in here. Maybe not. Yeah. Yeah. Oh. No 1700s. No, it's more 1700s. I just had them the other day. I'm sure I put them. Sure where I put them. Gabby, well, you didn't have to leave. Could have shared the chair. Yeah. Just appropriate mounting pressure because you want pressure to help thermal wicking. Guarantee thermal paste gets spread out as thin as what it can possibly get. Big old 35 volt 100 microfarad cap. A couple of these big bad boys. Big old 35 volts. I don't even think that would be terrible to use on a GPU, to be honest. Could you use it? Maybe, but it'd still be terrible. Yep, just try to do even mounting pressure. It's what you want though. Just even mounting pressure. Make sure it's good and even. Yep. Yeah, and that's also how our skin works too. But also, like let's say like on my when I do lapping in that too, with like extreme lapping, so lapping the CPU die, lapping the IHS front side and back side to lower it so that way it makes better contact with the actual die. I have to use a very small and or custom sand them down actual back plates so that way I can get proper pressure. If not, the pressure's just not there. The thermal wicking's not good enough. That's generally what I do for winters. Make sure I use all my appropriate hardware when I'm doing everything for cooling. For CPU and GPU. Proper cooling. Yeah, exactly. Yeah. Yeah, and the same thing with nickel plating's not the greatest, but I mean it's not terrible for the thickness of the nickel plating, but it depends on how the nickel plating is done too. Actually, that also matters how the nickel plating's done. DeBauer, I think, did a video about that one. Him making his own blocks, and he showed like how there's so many different ways. Yeah, I mean you still have conductive paste nowadays. You can still buy Arctic silver. Yeah, they still make Arctic silver. As liquid metal in it. Um, Gigabyte uses liquid. It's liquid metal, gallium, and other kinds of liquid metal. Tin. It's a thermal paste liquid metal type. It's not even liquid metal. They say it's liquid metal on their actual on their actual cores for their one GPU, for the 5080 or 5090 certain model. They use a liquid metal. It's not. It's an actual tin thermal paste, um, that is infused with a bit of liquid metal. Yeah, fake liquid metal. Yeah. Because they're claiming it's liquid metal. It's not. That is still technically a thermal paste. It's just an infused thermal paste with liquid metal, like Arctic silver. And a lot of people thought Arctic silver had actual silver in it. It doesn't. It has solder, or no solder, liquid metal. Gallium based. Again, for liquid metals, it's not all 100% gallium, by the way. A lot of people think it's 100% gallium. I don't even know if DeBauer's is 100% gallium, to be honest. DeBauer's might be. He might have more of a pure gallium-based liquid metal. I'm not sure on that, though. He should make a video of him showing his thermal paste, or his liquid metal versus others. Because not every liquid metal is actual pure gallium. You can mix in tin and other metals into it that actually make it so it's still liquid metal. Yup. And call it metal. Exactly, right? Yeah. For what? Did he always talk about the composition and performance of what? Of different liquid metals already? He already has a video like that? Or you talk about that GPU, the gigabyte GPU that has liquid metal. Oh, of liquid metal. Oh, okay, yeah, yeah. See, I've talked about it before, and a lot of people didn't believe me about how liquid metal is not all gallium, 100% gallium based. They're thinking, a lot of people thought it's just gallium. It's not. If you can get a pure form gallium liquid metal, pure gallium, that's gonna cost you a lot of money. Well, companies want to save money wherever they can. They'll add in tin. They'll even add in indium, which gallium eats indium. But they'll fucking add in indium into it to save money. Well, it'll just eat at the indium in there. It'll be part of its own form into the gallium mixture. And there you go. We save money because indium is fucking cheap. Yeah, tin. Yeah, it would still technically be possible to spread. Maybe adding in the tin does help it stick a bit better. Right? Maybe it does help it stick a bit better, but I'm pretty sure you would be able to spread pure gallium. Yep. And then with pure gallium too, if you really wanted, you could make your own custom IHS basically with it with pure gallium that allows it to eat into the copper layer and fuse itself with the copper, and then you can just sand it down, add on more liquid metal, and you won't have to worry about the liquid metal drying out too quick onto you as well. And then you'll have a really good surface to work with. It's a test I'll be doing in the future too, is making your own IHS, a gallium IHS instead of it being nickel plated, because you're also gonna lap your CPU, use the actual liquid metal, let it sit for a day or two, rub it off, or rub it back around, whatever. Let it sit again, and then check to see if it's actually fused itself into the copper IHS. And that way you don't have to worry about the actual indium or the gallium, drying out. And then drying out and either A, destroying your GPU or CPU. I suggest liquid metal on, so they've, oh yeah, they probably would. I mean, even I think that Gigabyte, because I didn't really watch the Devour video. I more or less listened while I was doing soldering and that on the 770. So he said like it even spilled out a bit. It even spilled out. If that liquid metal, that liquid metal infused thermal paste, did spill out and actually touched some sort of SMD or something, it would short circuit it 100%. There's no ifs, ands, or buts. There's that amount of liquid metal in it that it can actually short stuff. That's why I think he said they did like a pad or something around it. Yeah, and gallium eats aluminum. Yeah, yeah. It oxidizes aluminum, makes it extremely brittle. Yeah, pretty wild. Pretty wild. Okay, but I should probably get some sleep. Yep. Yeah. Yeah, gallium is very corrosive for other metals. Sure is. Yeah, I'm planning to be around there, especially by the end of the season. I'm actually planning to be around top three. Last year I ended up at top four in Canada, so I'm hoping I can be around there again. I just gotta work on a bunch of globals, and we'll see how we do. Again, it's not like I have any new GPUs. I only have 3070 Ti. I just gotta beat all my old records and try to get every single record to get the best points I can. Is that gonna give me the best globals? Probably not, but it's what I can do. We'll see what I can do. Yeah, just try to look at points that you haven't done already and do them. So that way, because you're not just looking at your season, you're looking at your career for it, right? You're looking at your career. So look at your career, see what you can actually improve on. I'm working my way to get all 30 points and up on my career. I'm getting close on 30 points and up this season. Same thing with career for hardware. Hardware points. I think my lowest hardware points on career now is like 26 points. So that's not bad. I think you'll do just fine. Just look at stuff you need to do. Rerun benches that can give you some more points. And try to leave yourself room for next year too. Can 14100F be that good? Maybe. Pretty sure that the G6900 and G7400 are gonna be your 2-core. Or 2-core. 4-core, yeah, I guess 14100F could be pretty good. Yeah, agreed. Agreed. Depends. The 12th gen has some pretty good efficiency. It depends on the bench too, though. All right, I'm ending it. I'm ending it. All right, all right, all right, all right. Yeah, yeah. Thank you guys for being there again. Hopefully tomorrow I'll have a bit longer of a stream. We'll see. We'll see. I'm gonna get some decent sleep because I've been up for almost 2 days now. So I think I should probably get some sleep. Yep. Again, thank you to all my viewers, subscribers, and donors. You guys help this channel more than you know. I'm gonna end this one here, and we'll be back at it tomorrow. We'll see tomorrow, and then we'll go over the GTX 770 again. Might do some soldering tomorrow. Show how to do some soldering because I need to add more caps to it anyway. So might as well. You got it. Up those likes. So I hope everyone has a good night, good day, good afternoon, depending on where you live. As always, don't forget to get her done. Peace. Take it easy, guys.